Boob.
So, Rumpus, was that directed at me?
Or at me.
These poor little FFers, your imitation.
No, your black was on. I was the mic. I can't be a second.
Remember that the
You
after
might
show
think that, but I couldn't
has
possibly comment.
Yes, it was partially directed at you, yes.
I thought so.
What was
The rest
that,
of
Alan?
the
I
way
couldn't
was
hear
that me?
And Barney. You and Barney both.
Good. That means we're doing our job well.
I like
Exactly.
the fact that Barney's a nice guy. He's trying to engage. He's trying to be nice. I think it's good that people are nice and are prepared not to accept the nastiness of the world around them, and they try and put an optimistic view on it. Brilliant. Love those sorts of people. Great to be associated with them. So that's fine. We need people like that in the world. But they
I just think, and genuinely I mean this, right? If we always come over as sort of nasty, aggressive, or pushy maybe with them, right? I think sometimes these people are a little bit willful and they do have this amnesiac and they do press the reset button all the time and they stick to their ideas. But I think it's more about the overall debate, not those people. So I'm not trying really to convince Travis or even Montreal or someone. But I think if we show, I was always taught, and you know this is we discussed this before, I was taught never to punch down, right? So if you're in a position of superiority, exactly. You never ever punch
Come
down
on, man,
on
you're
someone.
British. You're British,
I know exactly.
These people, like the Plain Truth and the Rileys and things, they are asserting things without any foundation and just based on opinion, and they assert that you're wrong. And they, for instance, they make demands upon us to do an experiment to provide this citation, but they don't expect when we do the reverse. Say, okay, you give us a citation, you do experiment. It's not equal. They are demanding things from us. They're asserting things from us. And people like Riley call people liars all the time. I mean, Montreal's constantly saying we're talking out of the sides of our mouth. I don't make comments like that, sort of sneaky, underhand ones. They
Really?
do. They assert things. But
you do an equivalent, Rumpus. You do say that they're utter morons and they're idiots and they're ill-educated.
That's an objective measure of what they are, unfortunately. So sometimes you have to show how the brutal objectivity has to be dispensed. But I don't accuse people of being liars. I don't accuse people of being malicious like they do. So I am not punching down. These people are in our faces being abusive, and if they were just meek, if they were just humble in their stupidity, I have a completely different attitude to them. I would refuse to accept aggressive ignorance and trying to tell me what's what about the world when they are completely wrong, and then demand that I give them experiments, citations, facts and things, and they don't understand anything, and I have to fill in education they've missed for 5 years in their teens. I'm sorry, that's not punching down.
Sorry, the Rumpus, you don't have to. Like, you really don't have to. Go away. Go away, and you never, ever have to see any of them again. Right?
Barney, I love man. Well said, bro.
You are choosing to be here. You are choosing to engage. Wait. You said your piece. I waited patiently, right? You are choosing to be here. You are choosing to engage. You are using the same, like, from my perspective, you yourself, I agree with you. You are correct, but you are using the same kinds of tactics and structures in your argumentation as they are. You will blanketly assert something. You will offend somebody. You will, when they ask for clarification or engage in a conversation, like today, the what's his name? The Plain Truth was asking me for clarifications, was engaging in what I was explaining. We were going through it. You jumped in the middle of it and started yelling, "This is all irrelevant. This is all irrelevant. You don't need to know any of this. All you have to do is accept that the Coriolis is true." And like, for fuck's sakes!
You're going off on a tangent. You're allowing him to take you along a trick that they deploy, which is to get the order events and things, as though that's somehow relevant to the theory. And you were allowing him to use a debating ploy to confuse the issue, and therefore it was all irrelevant. And my comment was entirely justified. And as for your other point about using something, I do not, for instance, try and use deviousness or lying, which Plain Truth doesn't.
But that, so much. What you have just said, for me, like strategically, tactically disrupting a conversation which is ongoing between two other people. because you see that they are trying to
That was after 10 minutes, Barney. I
some-
didn't interrupt you in the middle of your explanation. That was after 10 minutes you went through that, and I had to point out in the end that this was a debating ploy that he was using. I didn't interrupt you in the middle. So the suggestion with the implication you're making is that somehow I was disrupting your conversation. I made it at the end of the points that had been made, and to suggest that I was somehow trying to sabotage your explanation, I'm afraid, is unfair. I made the point at the end because he was using this trick, as flatties always do, of trying to get the order of these things and the motivation of things, whether that's entirely irrelevant to the science.
It is entirely relevant to the science. It
Right,
was the
why did you
conversation
take
that
10 minutes
it
on
is
it
the
then?
conversation that was going on, and
Yeah,
you
no, I
didn't
left
wait
that
for
happen.
the.
I did not stop you. It was when you came to an end of that, I decided to sum it up. Now, you might have objected to my summation, but I did not stop you engaging with him on the subject. I let you go on and on for about 10 minutes on this irrelevant tangent, but I was happy to let you do it. I did not stop you.
It might be irrelevant to you,
And I didn't
but
stop
it
you.
might be relevant to him.
And I
And the same thing where at the end, where he became uncharitable, and when he started being obnoxious, like that's the thing. If people in the hangout are refusing to talk to him, are calling him an idiot, are insulting him, are telling him that his questions are irrelevant and that they're going to inform him about what relevant is, yes, of course he's going to become belligerent. Of course he's going to become uncharitable. Of course he's going to start trolling. Like if he's being trolled, of course he's going to start trolling back, right? I like the guy that Jose threw out. I have no objection to him being thrown out, and I have no objection to being belligerent to him, because he is deliberately just derailing the conversation.
Yeah. I don't think you're aware of quite what's going on. I mean, you're not quite as I don't think you've done this quite as long as I have. I'm aware of the tactics they're employing, and I did not stop you engaging with them on that tangent. I was happy, well, not particularly happy, but I was happy to let you carry on going down this irrelevant tangent, and I did not sabotage what you were sort of implying. You said I stopped you in the middle. You went on that for about 10 minutes, and I let you do it. I didn't interrupt at all. So do not claim or imply to other people that I somehow sabotaged it, because I did not. It was at the end of that point I then summarized and saying that last 10 minutes or 5 minutes was irrelevant. So I'm afraid you might not like that, but I'm afraid it was irrelevant to the subject at hand. And I think you're a little bit naive, I'm afraid, into the tactics.
No, I'm a lot naive. I try to be naive.
You are, yeah,
I
well,
think
that's nice. I mean, I agree. That's a nice thing to be. But I think you're not quite aware of what's going on sometimes.
I am. It's irrelevant. It's irrelevant because if you get into a row, if you get yourself drawn down into the mud and shown for the same kind of person as they are in that context, if you are equally belligerent, if you're equally trolling as they are, then you are equal as they are. If you are patient and knowledgeable and explain the concept and explain it in a way in which they can understand it, and if they change the framework, explain it in their framework, in the way that they are asking,
to a certain extent,
then they will have nowhere to go.
But the trouble is, you're indulging in an irrelevance. And I'm happy to indulge them for a little bit, but after a point, you realise they're doing this deliberately.
Irrelevance for what? Irrelevant to the conversation, or irrelevant to what?
To hand, to the main issue at hand.
What is the main issue at hand?
Well, there was a discussion was on the Coriolis, and he was busily trying to get you involved in when the phenomenon occurred and when the investigation was, which was not relevant to the actual technical discussion. Now, as I say, I didn't stop you doing that, and you shouldn't be implying that I did. But it was an irrelevance to the actual substance of the matter. And he was doing that to get the order of these issues to try and obfuscate and confuse the issues. And we shouldn't be allowing them to do that sort of thing. And I don't think you're quite aware that's what he was trying to do. But anyway.
Okay.
I've no objection to being nice to people. And I say, if people are just generally stupid or ignorant, then I'm more than happy to engage them. This is not a guy who is interested in exploring the truth. And I know, and I'm happy for you to go somewhere down the line of you saying you indulge and get on board with their point of view and sort of try and drag that. But there's a limit. Perhaps, I mean, you're very patient with them, and that's nice. That's very nice. But I think.
But we're not here working to a schedule run. But see, it is about the debate, yeah. And the plain truth, whether he's doing those tactics or not, we are here to have a debate. We've gone around the circles many times, haven't we, on the same subjects, right? Lots of times. So we're not running out of time or something yet. And I think if we engage more nicely, I do agree with Barney, we are more effective because it gives them nowhere to go. They've got no quarter. Whereas the minute we get into the utter moral and that, it's just very easy to point at that. And I think you're naive in not realizing it makes you a less good debater, because I think you've got all the knowledge much more than me, certainly. But I think you undermine your debating capability, because the minute they suck you into the mud, it's easy to say, "Oh, Rumpus is rumpusing again," and the name they give you.
No, I'm afraid it's sucking into the mud. I avoid getting into the mud. This is when he was talking about the aeroplane stuff, and he said, "Oh, this is rubbish when you go from the pole to the equator," and his response was not to engage in the argument and say, "Oh, that's rubbish." So I think when people adopt an attitude, you've got to counter that attitude problem and say, "No, you're an idiot. The problem is your understanding," and you've got to make it clear. If you don't say to them, your understanding is the problem, or your ignorance.
Right. I'll make a comparison.
You've got to make them think. Hold on, am I not thinking properly? Am I not? Is my knowledge a problem? And you have to hit them with a hammer. These people do not take things subtly. To make them have a change of attitude. Now, okay, you could argue you might put them into a bunker mentality mode, but this is what, for instance, atheists do with religious people. You have to hit away, bang away, and eventually they start to crack. And this will not happen if you use subtle tactics. I mean, sometimes you can. Sometimes you can have a devastating argument. The trouble is, they don't recognise a devastating argument when they meet one.
I'll illustrate by comparison. I think that you're a less good and effective debater, and they would actually fear you more rather than inviting you on, and then you're up the garden path, then you've got conspiracy cats moment. They would fear you like they fear Bob the Science Guy, right? Because Bob has a very, very congenial way of talking. He's very effective. I don't think he's actually as knowledgeable as you are, Rumpus, dare I say it.
Well, I think Bob more abrasive tactic than I do, although he doesn't call it. He swears at them and things quite often. I don't.
I think they run scared from Bob quite often. Is my opinion, yeah, because I think he's got this congenial manner. Yeah, I mean, I think he's quite sly. Don't get me wrong; he's a sly old fox, right? But that makes him a good debater. And I think he thinks first and he talks slowly. And I think it's just anyway. It's.
I could argue the speed of delivery might be yes, and I might take that point. But
from my perspective, I am exactly halfway in between the Rumpus's point of view and Barney's point of view. I see merit in both of their arguments about how this should be approached. So I don't even. If I had to vote, I wouldn't even know which one to vote for.
Rumpus,
I don't swear at people, you asshole.
Sometimes you require a hammer. Other times,
Barney, Rumpus, if you
Bob
guys
is one of the best
I think we should show you into one person.
Yeah, I agree.
Rumpus, don't change, mate. We need idiots like you on our side.
Hey, Ali, what's up, man? I didn't know you were here.
How you doing, Montreal?
Good.
I agree with whoever was just saying that you pick the right tool for the job. So you meet every situation with whoever you're dealing with. Sometimes it's okay to call them an idiot if they're an idiot.
Can I just say,
there are people whom I cannot have a conversation with. People like Pete, Ellie in his bad mood, right? And then there is no conversation and there's nothing to add. If there is a conversation going on, I'm willing to follow the conversation wherever it goes and be sincere and honest about what I'm saying. What I kind of object in your approach, Rumpus, is that you always are giving them a way out, because they know that if they are cornered, they can just say something stupid or something provocative. That will get you so far off.
You're great at picking out other people's faults. How about looking at your fucking own before you start picking on other people?
And at that point, the conversation just devolves.
You guys are hilarious, man, criticising that guy. As much as I dislike the creep, you guys are funny, man. You really are. You don't even hear what you are saying. How dare you have the audacity to attack?
Can I?
When
you just said to look at your own faults, and then you said use guys.
I know I'm a false. I would agree with every single one of you, every single one that you
look
name.
at your own faults.
Then how do you make these blanket statements?
Apart from being accused of being a liar, you can say anything. You're probably right. Over talk, interrupt, blah blah, swear too much. I'll agree with everything.
By the way, whenever I
know
do
I'm
accuse
false,
someone of being stupid,
anyway.
I don't start off saying they're stupid. I've usually given them about 2 or 3 explanations of something, and then when they've willfully, like the Plain Truth did when I was explaining about the pole thing, and about the airplane coming from the pole to the equator, and then he says something particularly stupid at the end of it. I always combine a piece of abuse with the thing of reason why I'm abusing them. I never just say, some globalists will just call them, a git or whatever, and swear at them with no reason. I always combine the abuse with the reason for the abuse. I'm very careful to do that. So,
can I ask you a question, Rumpus?
You can.
With no disrespect, don't take this the wrong way.
I probably will.
Let's say you're in a bar. You probably will, yeah. Let's say you're in a bar now with your buddies and you're talking with them. Whatever, you're talking about Manchester United versus Leeds, whatever. How many times do you use the word moron and idiot in that conversation, face to face with somebody?
Not very often. I have occasionally, but I'm actually a very polite guy usually, you see, with people, because the people I associate with are intelligent, generous, kind, truthful, intelligent people, and I'm
thank you, Rumpus. Flat Earth appreciates you interacting with us. Good man. We'll take that as a compliment that the people you interact with are kind and
He wasn't talking about you.
Thanks, mate. I wasn't. We're talking about people in real life. So I never have a reason.
Keep it up. You're grown on me.
Right.
He was talking about his mates, Ali.
Yeah. So I never have a reason.
No, that was he's interacting with us. I was making a funny joke.
Yeah. And even when I've had people I've disagreed with violently, I've never resorted to just outright abuse. But on an intellectual point, when we're debating points and the logic is so clear and I see that people are willfully trying to dodge the issue, or I don't mind stupid people. I'm very happy to engage with them, and I don't want to abuse them unnecessarily. It's only the ones with attitude that try to lecture me with their stupidity that I get agitated about. So it's on those issues that particularly aggravate me. In normal life, I'm actually I don't swear at people. I'm actually very engaging and very polite. No, I don't use the word moron to people in casual conversation, no. Even if they're wrong, I'm very careful. If someone makes a mistake, to gradually ease them into where they made a mistake, so let's try and think about it this way. But when you're faced with people who are willfully trying to run an agenda, who are willfully trying to obfuscate, you've got to expose them for what they're doing.
I've got to say, although it pains me to say it at the moment, I 90% agree with Barney. Hiya, Barney.
He's a nice guy.
But I think I've accused the Plain Truth this before. He does employ what I like to call tactical stupidity.
Yeah.
He pretends that he doesn't understand, and although I would in the way that.
Well, yeah, because he'll agree to something on Tuesday, and then on Thursday, he'll say the opposite.
That's not true. He always says the same thing consistently.
Yeah, I'll agree. Yeah, that's one with Travis. He sticks to his story. You just make up shit all the time.
Yeah.
You really just need to
use.
You did, Travis. They were talking bad about you, mate.
No,
I'll give you
I was saying some of the most heinous things about you. I've been
listening the whole time, but
I'll give you an example. I'll give you an example, Travis.
Here's John. By the way, Travis,
no, hold on.
you owed him yesterday. Well
hold
done,
on, real
mate.
quick.
Good for you.
I didn't hear you. What?
Can I? Well, this is an example.
On,
you
John.
earlier
John,
in the
John,
conversation.
Hold on, I'm sorry, Ali, what did you just say?
Well, I said I like the way that you actually owned John yesterday. You stuck up and you pointed out exactly that he uses the same thing, and he kind of specifically used on you, kind of thing. That was it. And I was just saying, well done for, point out.
Okay. All right, John. John, in a second. Yeah, you can say what you wanted to say in a second, John. Listen, guys. When you make statements like willfully using tactics or whatever along those lines, you are implying that I'm here dishonestly and that I am not being honest. Okay, I am.
Mm-hmm.
If I make an argument that is a poor argument, yeah, that's on me. But I am not here, and I do not intentionally obfuscate. If I do bring in something that doesn't make sense, then that just falls back on my inability to be perfect. But I do not intentionally bring in anything along the lines that is going to be dishonest or deliberately obfuscating. So I just that's just not who I am.
Well, just the and I didn't hear the earlier part of Jose's show, but one thing that I did hear that you say was that you were talking about Coriolis, and you were saying, well, yeah, but how can you account for wind and atmospheric things to isolate the Coriolis effect? And then when Rumpus brought up the vacuum shaft, you were saying, oh well, it's not reality, is it? Because we don't live in a vacuum, which was completely inconsistent.
It was completely what?
Inconsistent. You were demanding earlier on that you would have to isolate all the atmospheric conditions, and then when Rumpus actually suggested doing a Coriolis test in a vacuum shaft, then it wasn't good enough because it wasn't representative of reality in a vacuum.
The other problem is that when you sit down and explain something at length, well, for example, why aircraft don't have to compensate, why Coriolis doesn't make airplanes go off course, because they're compensated. All right? That's the way that they're flown over a path on the ground. It's a very logical explanation by people who know what they're talking about. Yet
and it can be explained 12 days in a row, and the 13th day, they'll still bring it up.
Yeah, they just don't, there's no learning curve here. And that's the problem I have with it.
That's because the answers that we're given aren't satisfying our questions, and we keep asking it so that someone else will come up with perhaps an answer that actually stands the test.
And that's where I go back to academic prerequisites. Get them.
We give you the answer that answers the question and is the actual answer. We're telling you what's going on, yet you don't want to believe it because it doesn't fit your narrative.
Well,
with all due respect, Bob. With all due respect, you give answers.
Well,
if you send a message and the message is not received,
I've got a question about that. Then, so why does in a vacuum, then why does the ball not land in the same place directly above? Why does it move to the side?
We just went over this.
They just explain that at length. It's statistical variation.
Can we proceed with the conversation we were having and not get into explaining the Coriolis effect?
Barney, but why then, when maybe a month ago, my experiment of a train moving and you were hanging.
What does this have to do with the fact that
airplanes? Well, wait a minute. You've just said. Wait a minute.
Fly over
every single one of them. I'm asking what.
You're just going to talk over, aren't you?
Ellie, you're hijacking the conversation. We were talking about something. We were actually on a topic.
What's that got to do with Coriolis?
Ellie, we were on a topic, and that topic was not the Coriolis.
Yes, it was. That guy, John, brought up Coriolis, and then they brought up the vacuum.
Yes, Coriolis was mentioned, but that's not what we're talking about.
No, you were talking about Coriolis. Yes, you were.
No, we were talking about how to communicate with flat earthers and whether or not we can assume stupidity. Why do they forget things and stuff like that?
And then a vacuum chamber was brought up.
Ellie, everybody in the alley,
Coriolis. I'm sure someone said that.
He's still just talking.
Ali, stop and let others talk, or I will mute you so that people can be heard.
All right, Ali, Everyone else is agreeing to having the conversation that it was about.
But we don't address me because I don't get a chance to talk. Going to talk about what you were talking about because I'm
You're not
Ali,
about to talk about what we're going to talk
be
about.
quiet
Okay,
and
then
let
I'm not going
others
to address you. You
talk.
can shut the fuck up. Thank you.
Okay. So the way that plain truth appears to me right now is the same way that Sean G appeared to me when I first met him, and I talked to Sean G back then when he was a flat earther, and the same things would happen. I don't think that Sean G was dishonest in his intention. He would be dishonest occasionally in his tactics when he was pushed over the edge, when he was put into a corner, when his understanding of the world was challenged, right? When he would get to the point of doubting himself or not having answers, he would resort to the same tactics that Trumpus is indicating as dishonest. I don't count that as dishonesty. I count that as being human. I've seen plenty of Globers who don't have the academic prerequisites doing the same thing, right? Denying the obvious truths when they're presented by the opposing side. But if you
So
are
it's
willing
an
to be
intellectual
patient,
defense mechanism, is what you're saying.
yes, they
I can
have
accept
a
that.
set of facts. They have a set of facts which make sense to them. And you have to accept that. Like, if you think the opponent is completely dishonest, then you don't have a conversation with that opponent. You don't speak to them at all. There's nothing to say. They're not communicating. That's the thing that I have with Pete, the Aristarchus guy. Like, he's a clown. He's a bit of entertainment when I feel like it, but I've never been in an honest conversation about anything with him. I've been in honest conversations with the plain truth, including the one that I've had today. Now, they have a bunch of facts in their minds which they accept as true, which are correlated to each other in some way that makes sense to them. When you try to bring in a new fact that you know is true because it correlates to everything in your world, and it doesn't fit into theirs, they're going to reject everything that you're saying. But they will then be aware of that fact. When those facts accumulate enough that they start noticing the coherency in them, only then can they start accepting those facts. The fact that somebody comes over next week and has forgotten that one fact is not an issue for me. That is to be expected of somebody who doesn't believe you, right? But I don't need to get them to believe me. I need to get them to understand what I'm talking about, right? Just to understand what I believe, right? Not believe what I believe, just understand it. When they understand this fact and this fact and this fact and this fact and this fact, and see how they all correlate to each other, and see that they're all one coherent whole which explains everything, and that it has much more of an explanatory power than the model that they have, then you get a Jose or a Shanji. With this arguing and kind of dumbing things down to a point that they're no longer true, or strategically picking, being tactical and strategic about how to defeat the flat earth and which phrases you're going to use and when you're going to stop the conversation to defeat the flat earth, is stuff like I've watched Jose on some of the flat earth channels the other day, where he says, like, he is a Glober now, but when he looks at us arguing and not communicating and not understanding each other and jumping over each other to say, no, you're wrong about this and you're wrong about this and you don't understand, right? That gives him doubt again, because if we don't know it, then it's incoherent again.
I believe the term Jose used was doublespeak, Barney. Sorry to interrupt.
Doublespeak, yes. It is doublespeak. It is doublespeak if you don't understand that one statement is in one frame of reference and the other statement is in another. But you don't call him an idiot for it. You explain how it works. And if he doesn't understand, then you find new words. and you explain those concepts. Saying you lack the academic prerequisites to understand this is not convincing in any way. That might be a true statement, right? You might be right, but at that point you are admitting loss. You're no longer trying to explain. You're no longer trying to communicate. You're just calling that person stupid, and that's the end of the conversation. They get to continue believing what they believe because you have just granted that they cannot understand what you're saying, and you're done with explaining it.
I agree with your last part of your statement, Barney. But you see, what you're assuming here is that we haven't been where you've been. Like, you feel that you have the answers. You feel that you have to explain things to us. But let me tell you something. You're wrong, Barney. I've been where you are. I've researched a lot of things. I was a fanatical round earther. I was very interested in supernovas, black holes, you name it. I can talk to you about these subjects. I watched every Nova episode. I've taped everything. I've watched everything in science. I was the biggest geek in science that you can imagine. Okay?
Okay.
But there's certain things that do not make sense.
Agreed.
Now, if you guys don't see that, like the way you were just talking now, like you were preaching as if you have all the answers, as if you know, don't disrespect, Barney. I'm not disrespecting you. This is people that are in the education system. This is how they think. Like Rumpus, he thinks he's a superior intellect to us lower beings. You understand? You don't know. You sound very, very condescending when you guys talk like that.
I know.
We've been where you are. It's just that we woke up. We feel that we woke up and you guys are still
Here's
sleeping.
the problem. I can give you 5 things right off the bat right now that are incontrovertible and disprove the flat earth. Will that change your mind?
Of course. And may I say, Bob, you're one of the most respectful people there is.
Thank you very much.
I have nothing but respect for you.
I appreciate that. But, you know, the problem is we've given you those 5 things repeatedly.
No, you haven't, Bob. You've given me shit.
All right, then let's go ahead and do them. A gyro compass proves rotation of the Earth. A triangle
proves nothing of the sort. Okay, go ahead. I want to interrupt
there we
you.
go.
Ahead.
A triangle has internal angles of 180 degrees on a flat surface. Yet on the Earth, they can be up to 270 degrees. It's impossible on a flat surface. All right.
That's begging the question.
Those are just 2 of them right there.
On that one.
Let him finish, Truth.
No,
please let him finish.
All right, so I'm going to only go with those 2 things. And you've already told me that a gyro compass doesn't prove rotation of the Earth, and that's absolutely...
Why doesn't it?
I've already told you that on a flat plane, it is a geometric fact that a triangle's internal angles add up to 180 degrees. On Earth, they can be up to 70. It's not flat. Those 2 things, right, are incontrovertible.
You're roboting.
Yeah, Bob, it's pretty tough. It's pretty rough to hear you.
Any better now?
Yes.
Much.
Okay. But the issue with the gyro compass and the internal angles of a triangle, absolutely. A, the Earth is rotating, and B, the Earth is not flat. You know, these things have been presented many times, yet what's your first reaction when I say the gyro compass absolutely proves rotation of the Earth? No, it doesn't. Well, no.
I'll explain to you if you let me. I'll explain to you if you let me.
First, explain to me how a gyro compass even works. Show me you know how a gyro compass works. All right. What happens when you apply a torque to angular momentum? Where's the force?
A gyro compass maintains its rigidity in space. That's all I need to know.
That's
okay.
A gyroscope. That's not a
for this conversation.
It's a gyroscope, not a gyro compass. What's the difference? Tell me what a gyro compass is and how it's different than a straight gyroscope or a directional heading indicator.
A gyro compass? I don't think I know the difference. I'll be honest with you.
Well, then I'm going to show you right now, if it's okay with everybody.
Sure.
I will pull it up, and I want you to read what a gyro compass is.
Bob, once you've done this, I have a question from the chat. So just as a notification to people.
All right, let me see if I can share this thing.
Pay special attention to how it finds north.
And remember, Bob, if you're presenting something with sound, we won't hear it.
Okay, is that, can you see this okay?
I can.
Yeah, we can see
All right.
it.
Can you please read that right there?
Can you read it out loud because I'm driving? I can't
A
read it,
gyro
so-
compass is a type of a non-magnetic compass which is based on a fast spinning disk and the rotation of the Earth to find geographic direction automatically. Period.
Okay. Okay, so let me ask a qualification or a clarification, Bob.
Of course.
Okay, a compass, a magnetic compass.
Is nothing like this.
Okay, a magnetic compass gives me cardinal directions, right?
Based on the magnetic fields of the Earth, yes.
Right, right. Okay, so in using compass in a gyro compass, it's similar in the fact that it orients cardinal directions. Is that sufficient to say that?
It itself seeks true north in alignment with the axis of rotation of the Earth. Yes.
Okay, so whereas a magnetic compass orients through magnetism, how does a gyro compass find true north?
By gyroscopic precession due to the rotation of the Earth in which it's sitting.
Okay, I have to process that because I don't understand that right now. But that's
Which
fine.
is why it's a very, very strong proof, because if that wasn't the case, there would need to be some other similar phenomenon, let's say on a flat Earth, that made it point towards that cardinal direction. So the very fact that it does do that consistently, we can compare it to an ordinary compass, that uses the magnetic field of the Earth. The gyro compass doesn't use the magnetic field, but it does consistently show us where the cardinal directions or north is, which gives it a very, very strong proof.
From any location on the Earth.
I have another
Yeah, but
question.
how does the
Bob, this is
how
gotcha.
does
You
the
think this is a gotcha?
gyroscope
Hold on,
detect the
hold on.
rotation? No, wait a
Allie,
minute.
hold
How
on.
does the
Allie,
gyroscope detect the
Allie,
rotation?
Allie, you're interrupting, please.
Allie, I'm
Leave
sorry.
it to him.
Allie,
I've got
I'm
a valid
sorry.
question.
No, I know you do, Allie. Hold on, just real quick. This is Travis. So Montreal, I think, and you started talking at the same time, and so neither of you were being heard. But I have a question as well. So however we want to do this in order, go ahead.
Travis, please ask your question, and only Travis.
Okay. Is the gyro compass purely a simple machine? That is, it doesn't operate on anything else but its own power?
The gyroscope is spun by some sort of
No,
an
the gyro
external power.
compass.
The gyroscope disc itself is spun by external
and it's
power, but it finds its own direction. It has nothing.
Okay, so after it's spun, it orients itself appropriately. Is that what you're saying?
Yes.
Okay, I understand. Okay, thank you.
And it's I think the point is it's to true north, not magnetic north. That's the major difference in the two.
Right.
Okay,
We
so then-
use those for navigation on ships, and I'm happy to send Travis, if you would like, I can send you the tech manual for the Wizen 7 gyro compass that we use on ships for navigation. It explains it in great, great detail.
All right,
I also have 2 videos specifically on gyroscopes and gyro compasses they're relatively short and they would be very helpful for you.
Right.
I think.
So can I ask my question? Can I ask my question now, please?
Travis, are you done? Can I go to Allie?
Yeah, I'm good.
Can I respond to you, Bob? Because you were addressing me about this gyro
All
compass.
right, okay. I'll wait, Travis. Montreal, yep, absolutely. I'll wait. No problem.
Okay, so Montreal, you're on deck. You're up, and Ali, you're on deck.
Thank you for educating me on the gyro compass.
You're welcome.
It doesn't really mean absolutely nothing. If I knew it or didn't know it, doesn't mean absolutely nothing to our conversation. You're trying to do a gotcha here.
No, I'm not. I'm demonstrating
yes, you are.
without question.
Let me ask you a
the
question
Earth is
now,
rotating.
Mr. Scientist. I'm only a grade 9 dropout. Let me ask you a question. Is the Earth rotating?
Yes.
Is the atmosphere of the Earth rotating with the Earth?
Yes.
Asked and answered. This has been answered so many damn times.
Okay,
All right.
not asking you.
We're only going. Okay. All right. I'm only going to answer questions that are specifically related to the gyro compass, because I don't have time to go down 15 rabbit holes. I got patience.
Of course you don't. You want to talk about something insignificant
gyro
in the face of me. Get ready to humiliate you on this subject.
How can
grade
you
9
humiliate
dropout
him by asking a question that you've asked
humiliate
Ali, it's your turn.
a scientist on the Coriolis effect. Listen up, everybody. Go ahead.
Montreal. Here's
Let's
the
do
thing.
it.
Montreal, you say with all due respect, and then you disrespect people. Stop it.
You're done, Montreal.
You just don't like
Ali,
this.
Hey, Montreal,
No,
if you
I'm challenging you. You
Montreal-
insulted me. I'm challenging you now. Bob the science guy. I'm challenging you. Let's go on the Coriolis. Me and you, one-on-one,
Actually-
everyone listening.
Actually, I was very polite to you, and no, we're not going on Coriolis because I don't feel like going down the rabbit hole with you. We're talking.
Because
Because you know I'm going to
question-
embarrass
there'll
you
be the
in
same
front of all
conversation
your
about
peers
the
and in
compass.
full
It's got
world.
nothing on the
All right.
gyro compass.
That's why.
Montreal,
You
I'm
don't
done with
understand
you. Ali, you.
Please don't try to talk down to
This
us,
is the only thing-
common folk.
Okay, Ali, you can
Right.
either ask your question or I got to go.
All right, I'm going to ask my question now. Right.
Of course you
question
gotta
is-
go. Of course you gotta go.
My question.
Go ahead,
my
Ali.
question is. Yep, nice one. Cheers, Montreal. Yep. My question is, well, if the gyroscope is in the aeroplane, right, the spinning disc or whatever they're using doesn't necessarily have to be a gyroscope, just a spinning block or something like that, right? That they use in that, what you're talking about, the magnetic compass. What force is acting on it to point it in that direction? Because you said it precesses, right? So there would have to be a force, and it would have to be, as you say, at 90 degrees to the direction that it turns, and also to the direction of the spin. What's the direction that the object's spinning on, right? So what is the force that's if the aeroplane's in the sky and the Earth is rotating underneath the aeroplane? What is special about that it
Okay,
can
well-
actually detect the force?
Okay, well,
what is-
first of all, they don't use gyro compasses in airplanes. They use
Well,
the
magnetic.
Manchets.
You said magnetic compass, but it's got a gyroscope in it. That's what I mean. How does that?
Okay, no, hold on, Ali.
No,
Ali,
a
ask me a
magnetic compass
question.
doesn't have a
I'm
gyroscope.
going
Yeah,
to ask.
it was that one you were talking about anyway, right? Excuse me, I maybe misspoke, but inside that, what you said, you were discussing that compass or magnetic compass that they use, right? Is what's the force if it's in an airplane? Because you have them in, because we were talking about airplanes.
Okay, Ali, two things. First of all, that's not a gyro compass, and we're only going on gyro compasses. What you were discussing.
But that's got a
All
gyro.
right, now, Ali, if you interrupt me, I can't answer, and I've got to leave here in a minute.
But
Because you're patient.
you've got a gyroscope in it, right? Inside that. And you said it aligns to the rotation
All right,
of the
gentlemen,
Earth.
thank you very much.
He's confusing a gyro compass with a magnetic compass.
All right, now I'm going to
both
answer the question,
gyroscopes
Ali,
in it.
but if you interrupt again, that's the end of the answer. All
Right,
right.
what one are you
A gyro-
talking about?
All right, your
Right.
answer.
What one is it you're talking about? Is it a gyro compass or the magnetic compass you're talking about?
If you'll stop asking me questions, I will answer it. Now,
Yeah,
like
but
I
you
said,
don't need to add that shitty bit. Answer my question.
a gyro compass is on a ship, and it is self-seeking to true north because of its design. In airplanes, we have something called a directional indicator. Now, a directional indicator is a gyroscopically stabilized instrument. However, you have to set it to true north, and then it tries to hold that setting until it starts precessing. and then
So
you have to
but you
reset
set
it.
it there, so you set it on the, what do you call it, on a rose before you take off into the airplane.
You set it on a rose or you set it against the magnetic compass, and then you have to reset it every 15 or 20 minutes or so because it'll drift. But it's very
Yeah,
stable.
exactly. So you're actually, yep.
Okay.
Yep. So you're actually setting on when the
So
before
he doesn't want an answer, Bob.
before the
He just
airplane
wants to
takes
talk.
off, it drives.
All
to
right.
a
He doesn't
part-
want an answer, and I've got patience to see.
it
So
dri-
thank you
it
very much,
drives-
Ali.
It taxis
No,
to a
I'm on-
part on
Bye,
the runway.
Ali's
Wait a minute,
side.
Travis. It taxis to a part on the runway. It's called a rose, a directional rose. You get them in most airports. And what you do is the pilot taxis over
It's a
to
red
that,
herring. We're not even
and
talking
he
about that. We're talking about a
sets
gyro
that
compass.
compass.
We're not talking
He
about that,
sets
Ali.
the compass to
Bob
that
was
direction.
talking
and
about
then
the
you pilot
gyro
the
compass.
And
Ali.
that compass remains in that
We're
position.
talking,
It
we're
does
talking
he
about a
says.
gyro compass.
But
Ali,
it's
not-
corrected. That is a heading compass as well, and an attitude
we're
indicator.
not talking about that compass, Ali.
Compass. Bob
We're not
mentioned-
talking about that type of compass.
Bob
We're talking
just
about a gyro compass. He didn't mention an indication director in a plane. He was talking about a gyro compass
Someone
as
just
he
muted
chose
me
it.
there. That was kind of pissy.
I didn't do that this time, so it wasn't me.
I don't only play the muting. That
Yeah,
was
but
pissy.
fine. But we're not talking
I'll mute
about that type of compass.
Talk to
Why,
someone else.
Ali? Why are you changing it to a different type of compass from the one we're talking about? That's what nobody understands.
Because he has to, because obviously the gyro compass is very
No, I
powerful.
don't. The point I was making, it's got a gyroscope in it. You set it to true north. It
No,
remains in that
That's not what we're
it's
talking
not
about.
what we're
at all.
talking
Remains
about
in
though,
that
That's
Ali.
something completely different.
In a
rotation.
directional indicator, what Ali says is
And that's what
correct.
you guys can't understand.
No, in a
But we're
directional
not
Right,
talking
indicator.
about
Ali,
that. It's a red
we're
herring.
not talking about aircraft direction.
The gyroscope, sorry, the spinning gyro, the airplane rotates around
Not
that.
talking about that though. Talking
We're
about
not
gyro
talking about
compass.
that. We're talking about a gyro compass.
Yeah,
It's
I'm
a
talking
different
about
piece of
gyroscope.
equipment.
So you're talking about an old-fashioned telephone. We're talking about a mobile phone. Two different things.
You're talking. You could be talking about a
Right.
memes, or
Anyway,
you could be talking
Ali,
about
enough. This
form,
subject is
whatever
now.
which one you want to talk about. It
Ali,
just
be
basically
quiet,
is different.
or I will mute you.
Ali, can I send a link to you to the gyro compass? That way you can read up on it and just double check what you're looking at.
Thanks. But I've got a book on it. Don't worry, I've read it.
It won't matter. He won't understand it anyway,
Yeah.
Sean.
And the reason none of them want to discuss it is because it is a bit of a gotcha, because the very fact that it does process to north and we can test that against a normal compass is very, very strong evidence, as I explained earlier, that this is something which shows the rotation of the Earth. And that's why Bob has brought it up.
Yeah.
It's odd, though, that Ali B asked a question when he clearly didn't want an answer.
That's normal.
Of course, it's a tactic, as Rumpus says, to divert the conversation. We know that.
Wow. Is it a
You
bunch-
guys are using a tactic. You're trying
There
to
we go.
focus on the
Like,
gyro
We're
compass.
trying to focus on one piece of evidence that Bob said he'd give you, which is called a gyro compass. I think that's reasonable.
I'm going to fuck off now.
Okay, can I read you a paragraph
Yes,
from
Ali, please.
Wikipedia concerning your gyro compass?
Go ahead.
Yeah,
go
please
ahead.
do.
I'm not sure that you can read, but try if you would.
Shut up, Swarsinger.
Well, for fuck's sakes.
It's Cliff. You're better than that. You usually don't do such things.
I've been pushed to my limit.
Yes,
go.
by Ali. By
What do
Ali.
you got, Montreal? Go for it. What do you got, Montreal?
Okay. Since the gyro compass's north sinking function depends on the rotation around the axis of the Earth that causes torque-induced gyroscopic precession, it will not orient itself correctly to true north if it is moved very fast in the east to west direction, thus negating the Earth's rotation. However, aircraft commonly use heading indicators or directional gyros, which are not gyro compasses and do not align themselves to true via precession, but are periodically aligned manually to magnetic north.
Yes, we've already discussed
Perfect.
Exactly what
That's the
Bob,
difference between
I
gyro.
agree
that's
totally
exactly
with
what Bob was trying
Perfect.
to explain to you.
Yep,
And I'll be glad to go over it if you'd like. I've got.
Why don't you go ahead and
some
listen to it from Big Blue?
Mm.
He has more patience than I do.
That was Montreal. That was actually a perfect explanation of exactly what we were discussing.
Yeah,
What's
you
your point?
perfectly explained the difference between the gyro compass and the heading indicator. One is on an airplane, one is on a boat. Two
Yeah,
different
they
things.
use the other one to correct the other one when it's moving from east to west.
No,
That's
no,
what
they
I got
don't.
out of
The
it.
two
I don't know
aren't
what you
related.
brainiacs got out of it.
in an
Now you
aeroplane.
got confused.
Just
Now you're confused.
Can I just try this? I'm just going to try this, Montreal. So Montreal. So if you actually read what it said, and you said because if it's moving fast from east to west, that's why they use them in ships and they don't use them in aeroplanes.
I just saw your email.
So
you want me to add?
Sorry, you're on live. Ken, you're live.
Mute.
Do you want me to remove the existing 10 megahertz?
Alan, can you mute him?
I've got him. So that makes perfect sense, doesn't it? We're not using the wrong tool to do the right job. We're using the right tool to use the right job.
Can I ask a question?
I was hoping for a bit of response from Montreal first.
Okay, well, just let me know I'm in the queue then.
All I know is you guys look at one thing one way, and I look at things logically, realistically, and what you say just doesn't make sense.
Are you saying that that's an example of logic?
No, you're not letting me use my example of logic. You want to stick to your magical gyro compass.
There's
I want to
nothing
prove to you
magical
that
about
the
it. I
Earth does not
described to you
spin.
precisely how it
But
works.
you just you can't
It's
handle
not
it.
magical.
You can't
We
handle
use
the
it
truth,
to
can you?
navigate all over the Earth.
Montreal, wait a second. We were talking about gyro compasses. You brought up a heading indicator. You told us that a heading indicator and a gyro compass are not the same thing. How is that us using a magical gyro compass?
What I'm telling you is what you guys are talking about is irrelevant to the Coriolis effect and the spinning of the Earth. Irrelevant.
The question came from you
I
asking about
navigated all over
evidence.
the Earth by magic? Do you think
Can
I
I-
use magic to navigate?
Can I ask Montreal a question?
Go for it.
Montreal. So since you think that it's irrelevant to the discussion of Coriolis, what is it that you think that it's detecting? Does it detect something? So does the gyro compass detect something?
What I know about the gyro compass, wherever you started off, that's where it stays. So wherever they started spinning, that's where it spins to.
All right.
That's
That's
it. That's
absolutely
all.
what it doesn't do. That's
That's a gyroscope. That's not a gyro compass.
completely incorrect. What it
All right.
does
Now, I
is
just
it-
literally read you the definition of what a gyro compass was and how it was different than a directional heading indicator. And it went right over your head in one ear and out the other. And you're maintaining the exact same thing that you just said. Now, why is that you can't learn?
I could learn very well.
Then I
I just read you a paragraph. I just read you a paragraph that went against what you said.
No,
all right, we're going to
No,
open it
it
again
said
then.
precisely what he
No.
said.
I want to get
No.
back. Can you post?
No,
Actually,
it said when it travels from east to west
the wiki article
that it has to be corrected by an actual gyro compass.
No, it
Is that
doesn't.
correct or
That's
not?
a heading indicator,
completely
not the paragraph.
not the case.
I just read it to you.
Do not say that, Montreal.
You're
I
just
just
wrong.
read it to you. Well,
Mixing
then
things
you're
up.
smarter
all
than
over
what
the
in
my
here.
case
Montreal,
that he
hang on,
couldn't
hang on,
read,
let's try
and
this
then
again.
he demonstrated it.
Since the gyro compass's north-seeking function depends on the rotation of the axis of the Earth that causes torque-induced gyroscopic precession, it will not orientate itself correctly to true north if it is moved at a fast speed, thus getting rotation. However, aircraft commonly use a heading indicator or directional gyros, which are not gyro compasses. They're not using gyro compasses. Boats use gyro compasses.
Travis, hot mic.
Okay.
Do you realize they're talking about two different devices there, Montreal?
Okay, now, Montreal, that absolutely contradicts what you said. Now, do you understand that there's a difference between a directional heading
Okay,
indicator
I'll
and a
have to
gyro
yield on
compass?
this. I made a mistake. Okay, I
All right.
reread it again. I have to
That
yield
is
on
the
this.
right-
I'm sorry.
Okay,
No,
Perfect.
I appreciate
admire
that.
All right.
That's props.
I misunderstood
enough.
this.
No.
That's
Props,
I
Montreal.
admire it.
Yeah, props.
Good enough.
We own it. We own our mistakes.
All right.
And I give huge respect for that.
Okay.
Thank you.
Yeah. Now, Montreal, I've got great respect for what you just said, but you understand that what this very clearly says is that the only way that a gyro compass works is based on the rotation of the Earth. You see that?
Yeah, but Bob, since I don't believe that the Earth rotates, I can't see how this thing could rotate
Physics
to
does
north.
not care
How
what
does
you
it do that?
believe.
You have to explain this to me. How does
All
that
right, so
work?
hang on. Can I just make one point then, just before we go on? Do you believe at the moment, and I know you would like to see one, but do you believe at the moment, from the reasonable evidence presented, that the gyro compass does coincide with north in the same way that a compass would, i.e., both of them find north?
No, I can't possibly understand that. No, please explain that to me. How does this device find north?
All right.
Since it's based on a gyroscope.
All right, I'll be happy to show you. You guys want me to take a moment and show him?
Yes,
absolutely.
absolutely.
I think it will illustrate it perfectly.
All right. Do you want me to just, can you see me? All right. Now, if you were to imagine a gyroscope that is spinning like a clock right in front of me, okay? It has an axis of rotation. And that axis of rotation is what it spins around. That's called the angular momentum, coincides with that axis of rotation. Now, if I have a gyroscope that is pointing out along this axis right here, and I press down on it and put a torque on it, there's a thing called a right-hand rule, okay? So if you put your fingers in the direction of the torque, however your thumb is pointing is the way the force will act on that angular momentum. So if I have a gyro that's sitting like this and I press down on it, it will twist to the right. Now, are you with me so far?
Yep.
Okay, so the way a gyro compass works is that it has a gyroscope that spins up and it is locked to the horizon. It's locked in the horizontal. So if it's pointing due east, for example, as the day goes on, it will try and rise up to maintain its position. However, a torque is applied to it to pull it back to the horizon. That will cause it to rotate to the left towards true north. And the only place that that will not happen, where it will be in balance, is when it is aligned with the axis of rotation of the Earth. Now, it works the same way if it's pointing west or south or any other direction. It will twist around until it points to true north along the axis of rotation. That's the way a gyro compass works. That's the simple way. Now, it's complex to make it stay on the horizon. You've got mercury and ballasts and all sorts of other things. But that's the basic concept. It's locked down to the horizon. And as it tries to rise up, it's pulled back down, and that causes it to rotate. Does that make some sense to you?
I'm starting to wrap my head around it. I see a gyroscope basically manipulated in various ways to get it to point to a certain way. Okay, I'll have to check up on that more. I'll have to look into that.
Can I add a little tidbit?
Yeah,
I wanted to ask a question of clarification, if I may. What is the force pushing down?
Gravity.
Okay, that's what I thought, but I wasn't sure.
They generally use oil or mercury ballasts on it, but I didn't want to. The bottom line is it's pulled down to the horizon when it's trying to rise, but it's pulled down to the horizon, and that.
Oh boy, now you gave me some ammunition there, Bob. It's pulled down by a magical force called gravity.
Hold on, real quick.
It doesn't matter.
Well, that's a good one there.
It
Let me
doesn't
ask you a
matter.
question real
So
quick.
I'm the guy that doesn't understand this. Okay.
Well, the bottom line is a gyro compass actually confirms both rotation and gravity, but I only wanted to hit you with one at the time. So I'm just going to
Can
say,
I
for whatever reason, it's pulled down to the horizon.
Point
All right,
is,
can I ask you a question? Question.
yeah, go on, Travis.
Bob, you said the right-hand rule, correct?
Yes.
Okay, so when you were giving your illustration of pushing down on it, I believe the way the camera was facing, are you backwards so that I see your right hand, but it looks like it's your left hand? I'm just asking. When you were giving your illustration, were you pushing down?
My right hand. I was showing it with my right hand.
Okay, so
it looked properly oriented to me.
It was correctly oriented.
Okay, so what you're saying then is that when gravity is performing the force, it's performing the right hand rule. Is that what you're saying?
No, not at all.
Okay.
Gravity is providing the torque. Now, here, give me a second here. All right, so.
Bob, one
Okay,
question.
hold on,
Please,
Montreal.
Plain. One question.
No, Montreal.
Please,
this is Travis
please.
right now. Wait.
Yeah. One question at a time.
What happens? Imagine that you're looking at the sun. You know, it doesn't have to point at anything. But if you look at the sun as it rises in the east, during the day, the sun will rise higher in the sky. And if you have a gyroscope pointing at the sun when it rises, the gyroscope will maintain its position and try and rise up. If you pull it down, you're applying a torque in this direction, see? And the force of that torque will be where my thumb is, 90 degrees to it. So what'll happen is you pull down on it and it'll twist with your thumb moving counterclockwise. Got it? And that will go up until it gets to true north. And then if it passes true north, in reality, what will happen is your hand will be underneath and the thumb will point you back towards true north because you'll be raising up the gyroscope.
Right, but my question is, are you saying that that's what gravity does? Gravity is behaving like your hand. Is that what you're saying?
No,
which gravity? Newtonian or Einsteinian gravity?
All right,
which
we're
one?
not interested in answering that right now. What I'm saying is
Of
that
course you're not.
gravity is applying the torque. By applying the torque, the force that is applied onto the angular momentum follows the right-hand rule. Anything can provide that torque. You can take your finger and push down on it, and it will provide that torque.
Okay, so I guess for me, it's not helpful for me for you to use your hand and just simply describe gravity doing that.
Can you see my screen at the moment? I've got a compass. It's spun up, and I will apply a torque, and you will see it change, as Bob said. Can you see my screen?
Yeah.
Can you see the gyroscope here?
Yeah.
And can you hear it like buzzing away? It's actually spun up. Yeah, it's not stationary. I know you won't be able to see it too well. Yeah, can you see it?
I can hear it. Yeah.
So I can spin it in this direction slowly with no problems. I'm not moving it fast. Notice, yeah, as the east-west fast bit. And now I'm going to apply a torque in the opposite direction. You ready? You're going to watch it flip. Okay, ready? See that? Can you see it flipping? And now it's inverted. And now I can spin it in this direction slowly, and then we'll go the other way again, okay? You ready?
Okay, now make it point north on its own.
Can you see? Well, this one, okay,
That's
won't
not
do
a-
it unless I add a precession bar to it, because this is not a gyro compass, and it has not got enough mass to make sure that it points north. This is just a gyroscope, which I'm trying to illustrate Bob's point of the right-hand rule, and I'm applying a torque, yeah? So this is not something that we'll find north, just to be clear, all right? It was just a helpful illustration, because Travis wanted to visualize it. And by the way, this has only got 2 degrees of freedom in terms of its gimbals. So if you notice this, yeah, it's only got a degree of freedom this way, and then it can spin this way. It's not got 3 degrees of freedom, whereas I believe a gyro compass has 3 degrees of freedom. But you'll notice, see, I'm applying the torque, and it is flipping, which is exactly the same principle that Bob spoke about. Right, I'll go off
Well,
screen now.
a bicycle is a good demonstration of just a simple gyroscope. The faster you go, the harder it is to lean it over.
And I think the last thing I'll say on that point, Montreal, before we move on to something else, a cylinder does not make an engine.
That's a good
No,
point, too.
right, but you have to admit that you have to do all kinds of tricks to the so-called gyroscope, compass
I know,
gyroscope, to make it point north.
Camshafts, and you need a cam chain, and you need valves, and you need a cylinder head and gaskets to make an engine. I agree.
What is possible with this particular one, and I've done the experiment, is you can align it to north, and then you can be on a swivel chair and rotate yourself around, and it will carry on staying with its alignment to north. Yeah, and you can go and do that yourself.
Yes, that's the indicator in the place that we were talking
Great
about.
questions, by the way. Thank you very much for asking them.
Okay, so I have a question that was sent to me from somebody in the chat, and I'm sorry I've forgotten the name of you. I do apologise. For those who use the Gleason equidistant azimuthal map centered on the North Pole, your accepted distance to the line we call the equator is 10,000 kilometers. If you multiply that by 2 and by pi, that gives a result that is some 20,000 kilometers bigger than the accepted circumference of the equator, which is
24,900 and something, I think.
Which is 40,000, which is actually 40,000 kilometers. The result is something more like 62,000 if you do the 10,000 times 2 times pi.
The question came from Purple Harpoon, by the way, Alan.
Okay, thank you, Pip. Yeah, so would anybody like to respond to this question for Purple Harpoon? Please.
I would like to say that I did the math, and for a military presence to guard Antarctica at that diameter, it would take 10,000 naval ships, more naval ships than exist in the entire Earth.
Is that probably close to the number of ships that exist?
Well,
ocean-going
don't be
ships.
stupid. There's drones, there's balloons, there's all sorts of things, technology that they can use. There's not,
Were there drones in the 1950s?
60s, 70s, 80s.
And we've got no evidence of any of the drones or balloons. Who would provision them as well, right? So there'd have to be some support ships that those things were provisioned of.
They didn't like what I was saying. I'm spitting truth. And Schrodinger
Can
is
somebody address the question that was posed?
I'm answering Schrodinger's points, so he changed topics. By the way, I joined to talk about the gyro compass. I'd like to go back to that. Whoever Gauss W.
Chris, we are not talking about the gyro compass. We're talking about the question that was asked.
Yeah, no one knows because we don't know what the model is. So it's a moot question.
If you don't know what the model is, then how do you know that it's not a globe?
We know it's flat. We don't know what the model is based on distances and diameters and all that crap.
Don't you think you should?
No.
Well, why would you think it's flat?
Whoever Gauss W, he keeps muting me so I can't answer these questions. I think it's flat because it measures flat. It looks flat. It feels flat. It's not spinning. Hey, Bob, what does the gyro and gyro compass stand for?
Gyroscope.
And Bob's not here right now.
Gyroscopic compass.
Yeah, and we are discussing the length of the equator as well, Schrodinger, please, not the outer rim. But either way, both will be much bigger than required on the
Alan, may I make just one last statement? Sorry.
Yeah.
I just want to make the point. I don't have much longer. A gyro compass is a gyroscope.
Chris, we are not talking about gyro compasses.
Yeah,
that conversation is over.
I want to get my point.
Okay.
A gyro compass is a gyroscope. Don't let Bob or anyone else fool you. If you put a gyro compass on the land, it won't do anything different than a gyroscope.
Stop lying, Chris. It certainly will. You're just lying.
No, it won't.
Was it fact that the military didn't use the Coriolis in their ballistics as well?
I'm just telling you what people who used to be in the military and are in the military are telling me.
Wouldn't it be accurate to say that
members of the military on this channel?
Chris, why don't you serve in the military and maybe you'd learn something about these things?
Well, I have.
God damn it.
I don't.
Is a gyro compass a single axis?
No.
I don't serve for governments who killed their own citizens on 9/11.
No, I've got a question. If you've been told this information by people, and now it's been demonstrated to be wrong,
it's
why
not.
do you hang on to it?
There's a $20,000 special there. I gotta go, please.
He just came to do
Run, buddy.
Come in,
That's exactly
throw
what
some stones, inaccurate stones, claim that some guy told you something sometime from somebody, and then run away. That's great.
Chris, I've got another explanation for why you don't join the military. You're a chicken shit. That's my assessment.
No. It's very typical of Chris to come in, say something like that, claim he has to go, and just do a drive-by.
Yeah, I don't like that. I really I find that more objectionable than someone having a standing decent argument, which is kind of okay, yeah. But I think that drive-by stuff is it's a tactic to make points.
Yeah,
I don't think
he
it's
does
good.
do that often, which kind of bolsters Big Blue's point.
It's just disruptive.
So back to the question of the length of the equator. How would the flat earthers like to explain it, or would they like to give us a different map? One that can explain the distance from the North Pole to the equator being 10,000 kilometers and the circumference being 40,000 kilometers.
They have already both said that they don't.
They're not going to. They don't know. They don't know the shape. They don't know any of that, Alan.
Yeah, but they've said that.
Answer.
They do not have a model. They do not have a map. Therefore, all they know is that it is flat, but they don't know what the shape.
Which is why, if we use the Anthony Riley rule on that, they shouldn't be making any claims at all, because it's not feasible to say, without any kind of citations or backup, right? It's great to say, well, I think I know it's flat, I know it's not round, but of course I've got no idea about why it's flat. I can't really prove it or show you any evidence of the fact that it's flat. Yeah.
And what would be their independent variable?
Yeah, precisely. Yeah, I think I think it's one of the worst arguments, personally.
Yeah, I've been trying to get a flat earther to explain to me why longitudinal lines converge at the poles for 6 months now, and haven't gotten a single one to do that.
I like Bob's gyro compass example, and of course that's why Ali obfuscated and wanted to go off and talk about all sorts of other things. But I think the gyro compass it's easily verifiable. You can show that it points to the cardinal point of north. You can verify it against a normal compass. So therefore it is definitely exhibiting something, whatever shape you think the Earth might be. And then of course there's a coherent explanation linking, gravity, to why it does that. And I think it is a bit of a gotcha, actually. I think I hadn't considered how much strong evidence it is, because it's relatively simple as well.
And I do have the tech manual for the U.S. Navy's gyro compass that are on our ships, and all throughout that, it's a PDF. If you just search Earth or curvature, rotation, it's all throughout that manual.
Well, the device that's much easier to see and visualize will always be the Foucault pendulum, no matter what.
And if you want direct evidence for the curvature, it is the Eratosthenes experiment, as long as you use more than 2 sticks.
Yep. Bob and I got within about 30 miles of it.
That was flipping ridiculous. Did you see my thing on Alberoni this morning?
I hadn't looked at it yet, Bob.
Yeah, I watched that. I watched that this morning. That was good.
The only problem that you run into with Eratosthenes is you got to look to the heavens. You got to see the sun and have it cast shadows. With Alberoni, you can stand on top of a mountain, look down at the sea, and figure out the radius of the Earth.
Yeah, I think Alberoni is probably a bit better because. Okay.
Bob, can you type the name of that? I haven't heard of that before.
Alberoni?
Yeah.
Alberuni.
So yeah, he was an Islamic scientist back in what was it, about the year 1000?
1000 AD.
Somewhere around there.
Yep.
He's definitely going to be before the 1140s, because I suspect Bob dislikes a guy called Al-Ghazali as much as I do.
Who's Al-Ghazali?
He was the guy that
Go ahead.
he was the guy that basically convinced the entire Islamic Caliphate that mathematics and science were bad things, and we should concentrate upon the scriptures and the Quran.
And that's when the Islamic world basically lost its advantage in the sciences.
Yeah, you see, the problem that you ran into was prior to that, during the accumulation period, it was kind of interesting. What they did
was they got books from all cultures of the world and
Baghdad
translated
Library.
it into a standardized Arabic. And if you
Yeah.
could bring a book to the caliphate that he did not have in his library, he'd give you the weight of the book in gold.
He actually copied. He copied.
And he'd also copy them. Yeah, exactly.
Yeah, he actually copied what the Ptolemies did in Alexandria. When the ship docked at Alexandria, part of the customs check was to see if it had any scrolls or books. And if it does, those were seized and copied and given back. Though a lot of the time, allegedly, according to Greek rumor, the originals were not given back.
But the copies were given back. But so I think, the Alberuni is an excellent illustration. I think what will happen though is you will say, Anthony or somebody like that will say, oh, well, you're just using, sticks in the ground or something. I think Foucault's pendulum is very good, but with Foucault's, they'll say, oh, you're giving it little kicks with a magnet. Do you see what I mean? So there's always a gotcha. Sorry, Bob.
Yeah, but you see, the thing is, and here's the challenge that I did. Not far from me, we have the Sears Tower, the Willis Tower. And the Willis Tower is 1,450 feet above Lake Michigan in Chicago. And there's a clear view of a lake. Now, a lake doesn't even have tides to speak of. So you go up to the observation deck on that with 2 yardsticks. You put one by the window and you put one about 30 feet away, and you sight from the one straight down to the horizon and see where it matches up on the yardstick near the window. You can calculate that angle easily. And with that angle, you can find the radius of the Earth. It's simple.
Also, Slice Barkane did the Eratosthenes experiment with, I think it was 20 some odd people from around the world.
That's correct. And and when you tried to figure out where on Earth the sun was using those, it only fit if you used a large sun a long distance away.
So what Nathan said to Alberuni, because to the Alberuni experiment, obviously not to Alberuni himself, because Rumpus was for one point really promoting Alberuni, because I think it is quite a strong proof, quite a good one. Yeah, as you say, Bob. Nathan said, "Oh, well, you're presupposing that the Earth is obviously curved, so therefore all you're doing is you're verifying the presupposed radius of the Earth that you already know because you pre-assumed it in your experiment to try to find the radius of the Earth."
Well, actually,
no, you could presuppose that it's flat, and you just wouldn't get the desired result.
Now, here's the problem that you run into with that entire line of reasoning, and that is you don't presuppose the Earth is a sphere. You presuppose that the Earth is the Earth, and you measure the angle to the horizon. Now, that angle will be consistent, or that radius that you come up with will be consistent in any direction, at any location on Earth, and by over any distance that you can measure it. The only way that that's going to work is the only three-dimensional object that fits is a spherical body. So basically, you prove the sphere with it, but it's a direct measurement of the radius.
So again, I'll play sort of Huckleberry here. I think I've heard Nathan say, that in your presupposition, what you're doing is you're assuming that the horizon is something that you can actually sight upon, and actually the real horizon is much further, because of course it arises to eye level, and so it's just an optical phenomenon as distances go by, so what you're citing to isn't the real horizon.
And he is more than welcome to demonstrate that with the consistency that I can demonstrate it from the real horizon.
So I have a question for Montreal or the Plain Truth. Listening to the conversation that's going on right now, listening us listing these experiments, and you're just getting facts, you're not getting explanations, right?
We don't see it that way, Barnum. We see it as
Go ahead.
We see it as you observe and you declare. That's what we see. We see it as you guys think you know, but you don't really know.
Okay.
Well, then why don't you go ahead and explain the trigonometry of the Alberuni experiment to me and tell me why that's a declaration rather than a deduction. I'll wait.
Here we go with the big words and the this and that.
Trigonometry's a big word.
I told
What
you,
big word
I'm
did
willing
he
to
say?
challenge you on the Coriolis
He didn't
anytime
say
you
a big
want,
word.
me and you.
How
And you're
about
telling
right
me
now,
Bernoulli
sunshine?
effects and
Wait. Montreal, wait.
How about
Montreal,
right
wait.
obviously we don't know
now, sunshine?
Nice dodge.
it. Let's do it.
Montreal,
I'll hand you your
Montreal,
ass
you completely
right now,
dodged so that you could talk
sunshine.
about.
Yeah, go on, do it, Bob. Please.
Everybody
do
go
it.
on mute. Let Bob and
Yeah,
Montreal
let
go
Bob
for
do
it.
it. Go on.
Let's do it, big guy. Come on. I'm waiting.
Knock yourself out.
Go explain me the Coriolis effect.
I already have.
Explain me the Coriolis effect. Bob
Coriolis
the
is the
science guy.
effect. The Coriolis effect is the tendency of an object moving in a line on a rotating body to turn to the left or the right, depending if it's in the northern or the southern hemisphere. It accounts for the rotation of cyclonic and anticyclonic storms in both the northern and the southern hemisphere. It accounts for the trade winds and weather patterns. That's enough for right now. You can go ahead and take that from there.
Sure. Okay, right. So you claim the Earth is spinning, correct? Did you not hear me, sir?
I didn't hear you say anything about Coriolis.
I'm asking you a question. Is the Earth spinning? Yes or no?
Yes, it is. And we've already answered that. We're talking only about Coriolis, which is what you wanted to talk about, Sonny.
Oh, Sonny, so you're putting parameters on this discussion because you're afraid of what I'm going to tell you next, right?
You dared me to debate you on Coriolis. Stick to Coriolis.
Right. If there's Coriolis on Earth, right? We're first of all, we're debating Coriolis as it is on Earth, correct?
Proceed.
What do you mean proceed? Is that a yes or is that a no?
This is a debate on Coriolis. Proceed. Make your point.
Yeah, right. Because you know what I'm going to tell you next, right? Bob the science guy with all the answers
clue.
That talks down to us as mere mortals, right? So
is that a
if
point
the Earth
on
is spinning,
Coriolis?
sir. Yes.
Spit it out.
Yes, it is. And I'm waiting
Then
for your
make
answer,
point
sir.
without editorializing.
Get on with it.
I'm asking him a simple question so I
Montreal, it
can
would go a lot
proceed.
easier. Montreal, you're grandstanding.
I'm not
come on.
grandstanding. I'm asking him if the Earth is spinning.
Make your fucking point,
You're
Montreal.
grandstanding, you're going, Bob the great science guy, da-da-da-da. Come on, crack on, fella.
Crack on, fella. Who the hell you think you are, boy?
That's my way of very politely, without getting angry, because I'm someone
Don't
who's
you
very
crack
calm.
on, fellow me. You stay out of
Asking
this. I'm
you,
talking
fella.
to Bob
All right,
the
then
science
I'm
guy.
back in it. Get on with it, Sonny.
I'm talking to your high priest, Bob the science guy.
I'm no high priest, but get on with it, Sonny.
Get on with it. I'm asking you a question.
He's not high as
Is the
patrons
Earth
are.
spinning, yes or no?
Asked and answered, yes.
Okay, is the atmosphere spinning with the Earth, yes or no?
Yes.
The atmosphere is spinning with the Earth. Everybody heard him, right? Then you have
Asked and
no
answered.
Coriolis
Damn
effect,
it.
Bob the science guy.
God damn it. You're fishbowling it again.
Not fishbowling it.
Holy
I'm stating a
shit.
fact. I'm stating a fact, which you guys can't
Okay.
handle.
A fact.
Can you present an argument for that claim?
There's no argument. That's very simple. I can bring you the merry-go-round thing. Everybody knows what the Coriolis effect
So you were
is. Bring up
saying
Wikipedia. You know what it is. Don't try to weasel out of it.
So you're saying that because the Earth is spinning, or the atmosphere is spinning with the Earth, there is no Coriolis. Is that your statement?
Correct.
Okay, great.
That's exactly my
How
statement.
fast
You
is
need
the Earth
2
and the
reference
atmosphere
frames for the
spinning?
Coriolis effect. Correct. That is my statement.
Bullshit
How
alarm.
fast is the Earth?
That's
and the
irrelevant. Let me
atmosphere spinning?
let me jump
All
in.
right.
for
Let
Montreal.
Bob.
Let me
Let
jump
Bob
in.
go.
Let me jump in. Let me jump in real quick.
No,
I'm talking
actually,
with
no.
Bob,
This
nobody
is my
else.
debate.
Just Bob. Just
Yes.
Bob.
Just me.
Okay.
So you're telling me that the Earth and the atmosphere spinning together means that there is no Coriolis effect, correct?
That is exactly what I'm telling you, correct.
What is the Earth and the atmosphere spinning together at what linear speed at the equator?
1,200 and something miles, more or less, if I'm not mistaken.
1,038 miles per hour, but close enough for government work. What is it spinning at the 45th north parallel?
I don't know, close to about 800 miles an hour, if I was to guess.
How do you figure it out?
How do I figure it?
Yes.
I went to your magical calculations that you.
Okay.
Guys
So the Earth is spinning at
because I don't
734
believe a
miles
word of it.
per
I'm just
hour at the
repeating back
45th.
what you guys believe. It's not bad for a grade 9er, huh, Bob?
Are you just going to keep
No,
talking?
go ahead.
The Earth is spinning at 734 miles per hour linear speed at the 45th north parallel. There is a difference between the two. That is your second frame of reference.
No,
So
sir, you're absolutely wrong.
If you have a projectile sitting in a cannon on the equator pointing north, how fast is the projectile moving sitting in the barrel of the cannon? 1,038 miles per hour. When you fire that cannon north,
So
and
if
it is up, stop. When you fire that cannon north and it reaches the cannonball reaches the 45th parallel, how fast is the cannonball moving to the east?
I don't know, and I don't care how fast it's moving. It has nothing to do with anything here.
Okay,
Don't try to
that's
weasel
done
stuff.
then. That's done then.
What do you mean
Thank
it's
you very
done?
much. Appreciate your time.
What's very done? You said absolutely nothing here.
It's done. Wait, Montreal, I can answer that question. It's done because you don't understand what the Coriolis effect is. It's not
And
a
that's later
decoupling.
I understand it very well. I explained it to
Very
you
much for
very
playing
well.
Montreal. It was fun. How long did that take, guys?
The Coriolis effect is
I
not a
demolished
decoupling
you
of the
in front of your
atmosphere.
pictures.
About
I
5
demolished you in front of
Montreal.
everybody.
Montreal, the
completely
Coriolis
No,
effect
Montreal.
is not. Montreal, the Coriolis effect is not a decoupling of the atmosphere versus the ground. That's not what our model states.
You've completely misunderstood it, I'm afraid. You're mistaken.
Your
and Bob,
model states you
That
can
was
read
about
it in
3
any
minutes,
one of your
guys.
encyclopedias that for the Coriolis to take effect,
And-
you need two reference frames,
Pull
one
something up.
inertial and one non-inertial. Don't try to weasel out
No,
of
pull it
this.
up right now.
and by the
Pull
way,
it
I
up
want
right
to
now.
I want to make
It
one.
doesn't say
I want to
that.
make.
Pull it up, Montreal.
Come on, show us the citation.
Show it to us.
Please do.
Right now.
Yes, I would also love to see sources
I'm
because
on my
I
phone
haven't
right
seen
now.
a single source
Jose has
actually
brought
saying
this up
that.
many times. You guys know what I'm talking about. You're trying to weasel out of it.
No. You tell me which reference you're talking about, and I'll pull it up for you.
Yeah, just go ahead and show us there, man. We want to see it.
Yep.
We're really
Last time I
interested.
see it was on.
Would you
The
like
last time I saw it was on Wikipedia.
You want to see what Wikipedia says? Okay, I'll pull it up for you.
And by the way, Bob, proper protocol is now that you're done with him, offer him the home version of the game.
Would you like that in paperback?
Barney, you might have to stop sharing for Blue to share.
You got owned by a grade 9 high school dropout, Bob.
Because you are a
perspective is exactly where I would be if I thought that you owned Bob.
Yep.
I'm sorry.
Because you are a
but
grade
you own
9
nobody.
dropout, you thought you owned Bob when you didn't.
Yeah, exactly. I think
I think
You
highlighting
want to
those
try
factors.
again, Montreal? Do you want to try a different subject? I'm
Well,
game for it. I've got an hour to drive. I can probably took me what 4 minutes to demolish you on that.
They
I
Yeah,
get
you can do
another
it.
15 out of it.
In your dreams, in your dreams.
There it
They
is,
must
Montreal.
teach what the
Pick
word
another
owned
one.
means in 10th grade.
I spoke enough. Somebody else could speak now. My point was made.
Oh, your
All right,
point.
Blue,
My
take
point
it away.
was that
Yeah, you
I
definitely
think
made your point.
Yeah.
I
Blue,
think
take
Want
it
to try
away.
and make another one? So we
Point's
do
about
two
to get
more. We
destroyed,
can do
Montreal.
it.
You want me to read it?
I think they teach what the word owned means
Go
in
ahead,
10th
Blue, read
grade.
it up.
The point is you
Right.
don't understand Coriolis force.
In physics, Coriolis force is an inertial or fictitious force that acts on objects that are in motion within a frame of reference that rotates with respect to an inertial frame. It doesn't occur in the inertial frame. It occurs in the frame that rotates. The inertial frame is only necessary to determine if the other frame is rotating. Do you understand? That's a very proper way of
Yeah,
stating.
you just said 2 reference frames. Do you understand that?
No,
God
fucker.
damn, Montreal, you're fucking stupid.
I just explained it to you. To be proper in physics, you cannot say a single frame of reference is inertial or non-inertial. You need a second frame to establish the fact that one of them is rotating.
Right there in the
move in
top,
relation to something.
in the top line, it says a frame of reference, not multiple frames of reference or 2 frames of reference. It says a meaning singular, meaning one, meaning unit.
So, Montreal, you do understand, to know if something's moving, you need to compare it to something else.
For the Coriolis effect to take place, you need 2 reference frames, one inertial and one non-inertial. Whatever else you guys say, I don't give a flying
I don't give a
fuck.
fuck what you think either. I don't give a shit. Here it is.
Montreal, you're all.
Here it is in Encyclopedia Britannica in classical mechanics and inertial force described.
Okay, can I jump in real quick? Please.
Let's see. Where's
No.
Newtonian laws of motion. In a rotating frame of reference, an inertial force acting to the right. You see that? There is in Encyclopedia Britannica, they're not being proper about it. They don't even mention a second frame of reference, dumbass.
All right, there's no need to name call, okay?
You're going to put the marble scanner up, guys. I'm worried about his blood pressure. He will come and turn you into a pelt.
Look,
Again, it says
it is proper to call him a
rotating
dumbass.
frame of
It's
reference.
really simple. You don't. All you need to know is that you are moving in relation to something else. You do not need these 2 reference frames. This is where I think all the confusion starts when people explain it.
All right,
and then
so
people
let me
get very
jump in real
confused.
quick. All right, so the way that I'm just thinking about it right now is the 2 reference frames is the thing that is spinning and the thing that's moving through.
Negative.
That
no.
Yeah, no.
It has to be in the rotating frame of reference. It has to
okay,
be moving
so I have
in
a
the
question.
rotating
Okay,
frame
that's
of reference.
fine. If you wouldn't jump in real quick, that's fine. My question is, if you have simply a merry-go-round spinning, right? It's just a merry-go-round.
Yeah.
Do you have Coriolis at all? If it's just spinning on its own?
Not until something moves in that frame of in that rotating frame of reference.
That's the second reference frame.
No, it's not.
That's what they don't get.
That's what you guys can't understand.
That's not a frame of reference. That is an object moving, right? From the.
Are you okay? Hold on.
So,
okay.
Hang on, Travis. Just one sec. Let me make one statement. I think everyone confuses this even more by placing a merry-go-round, which is on the Earth. Of course, the Earth is spinning. Then you've got a merry-go-round going round. Just go with the simplest example, right? Which is your bullet going across the Earth. Yeah? Because it simplifies it. You've not got multiple things.
The Earth's not moving, Al. The Earth is not moving.
Well, it is.
The merry-go-round taken in
The
itself.
gyro compass disagrees with you.
Wait. The merry-go-round. The merry-go-round taken in itself is a good enough, simple system that we can explain this in. Now, the object, when you're talking about the frame of reference of an object, that means that object is its own, is always stationary. In its own frame of reference, no matter how the object is moving, it is always stationary. It is always at the 0 coordinate, right? So when you're talking about the object moving, that object's frame of reference just sees the merry-go-round moving around it. So that's not the second frame of reference that you're invoking, right? Now, the whole mention of 2 frames of reference is that in one of them, the Coriolis effect exists, in the other, it doesn't. That other one, for the Coriolis effect, is irrelevant. The only thing that you need to have a Coriolis effect is a rotating frame of reference and an object moving through it. That is all that you need. You do not need any other frames of reference of any kind.
Once that object leaves your hand, let's say, Arnie, that object is in a second frame of reference.
No,
if it's not attached, let's say.
It is not.
Wait, it is. How could you say it is not?
Okay, what is a frame of reference?
I agree. I'm just saying I agree with this.
Okay, in that case, Barney. In that case, wait. In that case, we have a fundamental misunderstanding of what a frame of reference is.
That's the problem.
We have two understandings of a frame of reference. One is on its own, and one is how it relates to the Coriolis effect. This is what you guys make your mistake on. You can have a million frames of references on the Earth, but when it relates to the Coriolis effect, you need two frames of references.
A rotating environment. We started designing it in the.
Sorry.
Okay. Please mute when you're playing things in the background or talking on the phone.
Whatever, Peter. Don't need to chastise me. I figured that out.
Okay. So a frame of reference is literally the coordinate system that you're measuring things in. Right? That's all a frame of reference is. The thing that you are going to consider as stationary.
And our point, and listen, and our point is that when you describe your world as a single reference frame, that is, the Earth is spinning, the atmosphere is spinning, everything is moving in the same direction with the same velocity, right? When you describe that, you're describing a stationary world where there's one reference frame. It's the same phenomenon, right? That's the issue. So if you have in your world, the Earth is turning, the atmosphere is rotating with it, it's all fluid that way. You cannot have a Coriolis effect if everything is moving within that same reference frame, doing the same thing. You can't.
Hallelujah.
You got movement confused.
Okay, so when you have a merry-go-round turning around, when you are in that merry-go-round and measuring from your position, distances, velocities, all of those things, you are measuring from yourself as though you are the origin of a metric system, right? When you measure in that way, you will detect the fictional forces. Coriolis, centrifugal force, Otvos, stuff like that, right?
Okay, what do you mean by fictional force?
A force that doesn't exist in an inertial frame of reference. If you go to the inertial frame of reference, those things are just moving in straight lines at constant speeds. There is no force acting upon them.
All right, so here's a question that I had.
The force is apparent because your whole system is turning around.
All right, here's a question that I had earlier on, and it just came back to me. If you have a merry-go-round in a vacuum, are you going to have deflection?
Yes.
Absolutely.
Yes. Same deflection.
How? Because you don't have atmosphere. In a playground, you have the atmosphere.
But you do have differential speeds.
It has nothing to do with the atmosphere. That's the whole point. Right. All that it is that if you're moving in a straight line in an inertial system and you're measuring it by a graph paper which is turning around, the line that your movement will draw out on that graph paper will be a curve. That curve will act in a predictable way depending on how you turn the graph paper. That is the Coriolis effect.
I think he thinks Coriolis is wind.
Yeah, I think so too.
No, right, but there's no deflection on. The reason why there's deflection on a playground when they show two people throwing the ball back and forth, the reason why there's deflection is because there's air resistance. When that ball leaves that person's hand, it then enters into a frame of reference that is not moving and has air resistance.
Okay, no. It was impulsed in a straight. It was impulsed in a line. It was impulsed in a line, and it's carrying with it the rotational speed of direction that you were rotating to start with.
So I've been presenting this video all day long. Please take a look at it. So when the merry-go-round is stationary, all the lines of water are going straight, right? When it starts twisting, it deflects in the direction of rotation, not back from it. It's not due to resistance of air. It is not being pushed back against the motion. It is overtaking the rotation, right? Why? Because the edge of the merry-go-round is moving faster than a thing which is close to the center, right? The center itself is stationary. It is just turning around its axis. The edge is moving rather fast. So the water that comes out will have that momentum. It will keep that motion and it will start moving here. Now, the merry-go-round, when you go from the edge to the center, the radius that it does in one turn is smaller than the outside. So that movement, that sideways movement, that tangential velocity of water will actually overtake the merry-go-round, right?
All right, I have a question.
That has nothing to do with air. That happens in vacuum. That is not just right. As long.
I have a question.
Go ahead.
Is there going to be a difference in the observation or the phenomenon if you have a playground merry-go-round with two people throwing a ball back and forth, and you put that same scenario in a vacuum? Is there going to be the exact same demonstration, or is it going to be different?
It will be slightly different, but
why?
Because of air resistance, right? Because the merry-go-round, the air does not move with the merry-go-round, so you will have a circular wind in the opposite direction.
I doubt you could measure it. I doubt you could even measure it.
That would be very, very, very minuscule.
We see it have no effect in the videos where people show this, right? So I don't think it's.
Let me show the video that I have. They're throwing a ball inside an enclosed environment.
Right. In the video, just before I stop sharing, in the video that I'm sharing, there is air in there, and there is that wind, that air resistance that you're talking about is actually trying to push the water in the opposite direction. It is trying to push the water in the opposite direction from the Coriolis effect, and you can see that the Coriolis effect easily overcomes that air resistance, right?
And those spokes of water are overtaking the middle, aren't they? Because I suppose they're going much faster with their tangential velocity. So
exactly.
They're overtaking the middle. It's like our bullet shot from the equator, right? I suppose. Yeah.
And if you were to kind of take a single droplet of water and plotted its movement frame by frame, you would see that every droplet for itself is actually moving in a straight line.
Yep.
There's a nice NOVA video demonstrating that. They put a camera.
Barney, aren't you showing centrifugal force here? Isn't that all you're showing?
Why don't you just go right ahead and interrupt me there, Montreal?
Centrifugal force. So yeah, in a sense, yes. Centrifugal force, Coriolis effect, and the Otwas effect are all the same thing. They are the tangential inertia of an object moving, or of an object in a rotating frame of reference.
Rotating, right. If it's not in a rotating frame, none of that exists.
So Montreal, are we still in La La Land?
But most definitely so. When it comes to the Coriolis effect as it relates to Earth, you are most definitely in La La Land.
Okay, well.
With all due respect, gentlemen.
Think we can
and that's why flat
clear.
Earth is not science.
Right.
Montreal, don't say with all due respect. You clearly have none.
Right. And
I have none for you, Roshinger. I used to, but I don't anymore.
That wasn't even Schrodinger who just spoke to you. But with all due respect, Barney, I think it's clear now why sometimes it's appropriate to call people stupid.
Now, plain truth, if you look at this video here, it shows you that with all the air moving the same direction as everything else, it still curves. You understand that?
In physics, a frame of reference or reference frame consists of an abstract coordinate system and the set of physical reference points that uniquely fix the coordinate system in standardized measurements. That's what Barney was trying to tell you, Montreal. It's not a thing. A frame of reference is not a box or a sphere or a flat plate. It is a coordinate system. Read up on it.
Yes, but what you guys don't understand is, in order to see the
we don't
Coriolis.
understand something. We've demonstrated we do repeatedly.
Wow.
Okay, let me rephrase that. What I think you guys don't understand is, you know what? I'm not even gonna bother. Go ahead, talk amongst yourselves.
They were making fun of me, Montreal. They weren't directing that at you. They were making fun of me.
I think what Montreal was trying to say is he is trying to put a reference frame with an observer, and I think that's where the disconnect is. I think that's the problem.
I think he's trying to parry what he's heard from Nathan. Probably.
I can say it the way that I understand it when Big Blue was reading the description of a reference frame. When he uses the word abstract, that takes it into the metaphysical. It's not in the physical world. So we don't live in a metaphysical world. We live in a world where we have fixed points of reference. And that's where I think Montreal and I are coming from, that we're talking about fixed points of reference. If one is rotating or not, that's what we're talking about. It's real, it's physical.
Well, you're going to have to differentiate between a reference point and a reference frame, which are very different.
Let me semi-agree with you, Travis. Not once have I walked out the front door and seen an X, Y, and Z axis painted on the front yard. It just isn't out there. I've looked for it. It doesn't exist.
I have one.
These are things we have. Oh, have you got? God damn it! You've got more shit than anybody, Bob. Damn it!
I know.
Why don't I have some? If you come up with an extra one, can I have it, please?
Yeah, I'll send it down to you for Christmas.
Okay, thank you. It's not metaphysical.
No, I was going to say that's the wrong use of the word metaphysical.
Yeah, it's
not actually. That's a perfect.
Yes, it is.
Perfect
That's
term
right.
for the Coriolis.
Yes,
it's metaphysical, magical, non-existent.
Yeah.
Okay.
When you don't have, okay, wait, hold on. Big Blue, when you step out your front door and there's no x-axis, there's no y-axis, that's because it's an abstract thought. It's an idea. Of course, it's not real. It's not physical.
Do we observe the rotation of weather systems in the northern southern hemisphere rotating in opposite directions? That is our basis in reality to say there is a force and effect, and we call that force Coriolis. So it has absolute basis in reality. You're just trying to, because basically, if you're using metaphysics in that way, you're saying it's an abstract theory that has no basis in reality.
Well, it's an idea like math, right? Math can represent a physical action, right? I can see two cars in an accident and try to figure out who was going faster by the skid marks and all that kind of stuff, and then I can represent that event with math, right?
Which isn't metaphysics, because it has a basis.
You're using the word metaphysical incorrectly, I'm afraid. I'm sorry.
It has a basis in reality, i.e., we are calculating something in reality. Yet you could argue, perhaps, as David Shapiro, whatever his name says.
Okay, so hold on. Okay,
lesbian dance theory might be metaphysics.
So the way
is not.
Okay, so the way that I would qualify what I said is, when I am representing a car accident mathematically, that's not metaphysical. When you're talking about x-axis, y-axis, or your inertial reference frames that are abstract in that way, that is metaphysical. That is an idea that's simply being expressed that doesn't necessarily have a basis in reality. So when you bring up a storm system, again, you and I are going to observe the same storm system. We're going to see the same phenomenon.
Mm-hmm. So therefore, our basis of our theory is based in reality, not in abstract. So it's not abstract.
Love and hate are metaphysical. Okay, they don't have a firm basis in reality where you can touch or point at those things, right? They're metaphysical. Yeah.
Well, not necessarily.
Everything
right?
abstract. Sorry.
Yeah, not necessarily, because you can't have a brother who punches his sister and say, that was very hateful, Johnny.
Well, it's the action then that is hateful, but you can't have an ounce of hate, right? So what I'm saying is, just because something is abstract, doesn't necessarily make it metaphysical.
Oh, I don't... Well, just
there are things that are abstract that aren't metaphysical, right?
I can have a latitude, a longitude, and an altitude, and that will describe a very specific place where I am. And that's where I am. In reality.
And that's also an X, Y, and Z axis.
That's right. When I build houses,
exactly,
I would pick a point and say that's going to be 0, 0, 0. X-axis this way, Y-axis that way, and Z-axis is up. That's very real.
Meter is an abstract concept, but it points to reality when I say that something is 1 meter to the front of me and 1 meter to the left.
And again, going back to, sorry, go on, buddy.
Plain truth. Based on what I have shown, did I satisfy your requirements to show that you do not need 2 frames of reference for the Coriolis effect? That the Coriolis effect is not an interplay of 2 frames of reference or an interaction of 2 frames of reference.
Yeah, I'm going to have to reflect on that further. I can't give you an answer right now.
Okay, that's fair.
The video I've been showing, did you see that? Plain truth?
I've been seeing it intermittently. Is that the one that was spinning?
Yes. So you do agree that there's no real serious air movement in there, right?
I don't know. I don't know what that is. What is it?
It's a giant spinning room.
I'm actually watching it right now. It's pretty cool.
Yeah,
they have a room that they are using for practicing artificial gravity.
Oh no, I didn't see those. I didn't see those. If you want to put the link in the
Artificial Gravity Lab.
I'm sorry?
The Artificial Gravity Lab on YouTube.
Okay.
I thought it was really interesting because the ball does exactly what it does on the merry-go-round, or at least close to exactly, with no moving wind. If you put a dome over a merry-go-round, all the air will start moving with the merry-go-round.
Say it again. Artificial what?
The Artificial Gravity Lab.
All right.
And it's going to show a picture of a guy with a sweatshirt on.
Oh, that ending, though.
Actually, I guess I could have copied the... I was thinking I don't want to type this out, but I guess I'm used to working on my phone. Yeah.
Ken, that ending, though, with the arm swing, that's beautiful.
Yeah. Oh, so your body's all calibrated wrong.
Is that?
It's amazing how fast you accomplish it.
Is that Tom Scott?
I don't know.
Yeah.
The first thing that came up was this.
It's Tom Scott.
Okay.
And that's the third time
he's just got a bit older. So is Montreal left, or is he still here?
That's a
I
heavy
still
receipt.
see him in the list.
He's still in.
I'm still here.
He's crowing in the chat.
Oh, right. About how he took Bob to pieces, I guess. Okay.
Initially, I would have...
No, nothing of the sort.
Initially, I would have agreed that on the merry-go-round, the wind would have a lot of, initially, some effect on the ball. But generally speaking, when you release that ball, it goes in a dead straight line. So the wind isn't going to make much of a difference in any way, shape, or form. No appreciable.
It has as much of an effect on the ball as when you kick it down a football pitch.
Not even that much. You're not throwing it that fast.
Like Neil deGrasse Tyson said, right? Goal.
You
Yeah,
seem to
right.
have no problem with
That force is a square of the velocity.
Holy shit.
Do you really have that big of an issue with a 1/3 of an inch deflection over, let's see, what was it, 34 yards and was it 43 yards in 5 seconds or something like that?
No, it's not the length, it's the claim. It's the claim.
What's wrong?
A third of an inch is a claim that you have an issue with?
Yeah, that there's Earth Coriolis. Yes, that's the claim that we have an issue
That's
with.
what you have an issue with. Yeah, right. Gotcha. I know it breaks your heart.
Sure, it affects the ball.
Sure it does.
Yeah.
But it doesn't affect planes. It doesn't affect
How many
hot
times
air
a
balloons.
plane is not a projectile?
It affects artillery. We proved that yesterday.
How many times do you have to
be here yesterday?
You're supposed to reach that every day, not every
that
hour.
it does?
Well, I would beg to differ that you've shown it at all. But
No,
here's my
you would,
question real
Travis.
quick. Okay, hold on. Here's my question real quick. Somebody said that the demonstration of the video that Ken was talking about, you said that at some point the air in the bubble will be rotating with the same. Is that demonstrated? Is that
No, he didn't say that in that room that would happen. He said if you put a dome over a merry-go-round, eventually the air would start moving with the merry-go-round inside the dome.
I would love to see that. That would be.
How many times are we going to have flat Earth reset?
Before you get to see it, tell us why we think that's going to happen.
You are. It's the whole idea of okay. Don't lambast me because of my failure to use the proper words. But you've got surface friction, right? So if you've got a rotating frame of reference, then the air is going to be affected by that spin, and at some point the air is going to be, I guess, it will find its equilibrium and maintain the same. It's just what you're.
That's a great answer.
Yes, that's a great answer.
Now, let me ask you the second part of the question. Why doesn't it happen without a dome?
I don't think it happens at all, but
why wouldn't it happen without a dome?
From our perspective,
it's not. I don't know. It's not going to happen. It doesn't happen.
I'll tell you why it wouldn't happen without a dome, because you have the friction of the surrounding air. The reason the thing the dome does is it removes you from the friction of the surrounding air and allows the friction of the merry-go-round to start spinning the air in the dome. But you did that was a great answer.
All right, well,
I just don't
Have you seen?
I-
There's a video online where they show some smoke. I think actually, and it may not be smoke. It may be actually CO2. From like a smoke machine. Yeah, and they introduce it into a spinning frame of reference, and you can see that going round, and you can see as it picks up speed. And then I think they also put an aeroplane in it, but a small model aeroplane. But you can see it very, very clearly how it picks it up, and eventually over time it gets up to the same speed. I mean, so it's well illustrated in a number of places.
The plain truth. If you're, can I just make a comment? The plain truth. If you are in a room that starts rotating, why would the air in the room with you not rotate as well? Or when you are sitting in your car doing 75 miles an hour down the motorway,
right? We're talking about a closed system.
with the windows shut. Why are you not being subjected to a 70-mile-an-hour wind in your face?
Yeah, I understand a closed system.
Well, there you go. It was a closed system that the video was in. It was a closed room with the air in it spun up exactly the same as all the rest of the contents of that room.
Correct. No, I don't have a problem with demonstrations that we can see and read and manufacture on our own. Going back to what Toady was saying, I think just a moment ago, with the smoke, my point is that because you're saying that our world's atmosphere is in lockstep with the Earth, show me that in a model. Show me that the entirety of that atmosphere that you have enclosed, or whatever, however you're going to do that, that it is all maintaining the same momentum.
Well, before we do that,
showed
why don't you
that.
explain to us why it would be different than the dome over the merry-go-round?
Right.
Tell me how the atmosphere would be different.
I'm not in the business of extrapolating an idea that we can see on a small scale.
It's fine to say you don't have an answer and you want to shift the burden back onto us. You can say that if you want to.
Don't put words into my mouth or twist the words that I'm saying.
But that's exactly what you said.
Okay, hold on. No, hold on. Simply because you say in a car you have in a car you've got a closed system where the air in the car is moving at the same speed. Taking that and saying that therefore proves that the Earth is spinning because we have no demonstration.
No one said that. Now you're straw manning.
No.
All
I've
right.
heard this.
Well, then let's take that analogy to its logical conclusion. Let's say I make my car a little bit bigger. Will the air move with me? And a little bit bigger. Will the air continue to move with me? At what point will the air no longer continue to move with me in my car?
You're not proving that is what the world is. You're just simply making an.
You keep begging the question, and he's not. Please.
Yes, it is. Yeah, you're assuming the Earth is that. And
what
it's
is
not.
a begging the question fallacy?
It's that when you are assuming your conclusion, you are trying to prove.
He's gone to the Anthony Riley School of Debate.
You're trying to prove a
He asked for an
cause.
example that was you asked for an example that was analogous. We gave you an analogous example, and your response is that's begging the question because we're using an analogous example.
No. Hold on. I don't believe I asked you for an analogous example.
Does the fact that there is a logical fallacy, according to you, disprove the conclusion?
It's only an informal fallacy at best in philosophy, but who gives a shit?
Yeah. But
it's not really
when you're trying
if you
to
claim that there is a logical fallacy in my argument, does that disprove my conclusion?
Say that again.
If you claim that I am using a begging the question fallacy in my argument, does that disprove my conclusion?
It might.
All right, look up fallacy.
Yeah.
And tell me what that is.
Yeah. Begging the question is when you say that there is a reason for this cause, and then you have an example and say, therefore, this proves the cause. You're assuming the cause.
You're taking a conclusion in the premise, basically. Any form of argument where the conclusion is assumed in the premise is a begging the question. Show me in his example where he's assumed the conclusion in his claim.
The Earth's atmosphere moves with the Earth because they're spinning at the same momentum, and that's demonstrated by the fact that we don't have 1,000-mile-an-hour.
That wasn't my question. I said if the air is not moving in my car as I'm driving down the road at 70 miles an hour, if I double the size of my car cabin, will the air continue to move with me?
Where's his claim?
And at what point is my car cabin so large that I will be faced with a 70 mile an hour wind?
All right. My point is that you are assuming the Earth is the same as that car illustration. That's what I'm saying. You're assuming.
Question.
But the plain truth, the problem is that you were not happy with the throwing the ball across the merry-go-round because the air wasn't moving with the merry-go-round. So we enclosed it, and you still weren't happy because you were still trying to say the air isn't going to go round. Well, why would the air not go round like it would go in your car?
I haven't been able to observe the demonstration of a merry-go-round in a vacuum, so I don't think I've responded to that.
I'm not asking it to be in a vacuum. You wanted the merry-go-round to have the atmosphere going round with the merry-go-round. We enclosed the merry-go-round. We even showed you the video of an enclosed merry-go-round going round and doing the very experiment we were talking about.
Are you talking to retard?
Does it demonstrate? Does it demonstrate?
Yes.
You know, here's the other
That was
problem.
a yes.
Here's the other problem that you have, plain truth, and that is that
Christ.
if you understand the principle of what's going on in the enclosed merry-go-round, do you have to physically observe that the same thing happens in a merry-go-round twice the size, or 3 times the size, or half the size? If you understand the principle of what's causing that air to go around, will it be somehow different based on size?
Listen, hold on real quick. I wish that I could answer your question. I'm trying to multitask with backing my trailer up, yada, yada, yada. So I can't properly answer your question right now, Bob. So I apologize, or whoever was talking to me.
A quick question, Bob. With my example of that room that's spinning, as you move towards the center, the tangential velocity of the floor is moving slower. Is there going to be wind there? Because that would be very analogous to the Earth, because you're going to be changing speeds as you move towards the center of that. As you move to the center of that room, so the air and everything has to be moving slower in the middle, doesn't it?
Yeah, I think it probably would.
That's
I have another question for this mythical roundabout.
I was waiting for a real answer, not yours.
That was a point that I made about the illustration that you can see, like where they injected the smoke in. You can see it moving at different speeds, and then they put the plane in different places. Because it would be very odd if it was the opposite. It would be very, very strange if it didn't move, the outside moved, and then whatever atmosphere or smoke or whatever was inside didn't move. It would be very, very odd if it stayed stationary, I would think. Go on.
Yeah, I would think so also, just logically.
You know, I would think that if you looked at the linear velocity as it went around different points of the floor, it would probably be different in different parts of the room.
Right, so if you had
it would match what the floor was underneath.
If you had a series of candles, there'd be more wind probably in the middle. I don't know.
Well, I think that if you had a series of candles, the flames would probably go straight up depending on where they were in the room, because there would be no movement of the air above the candle.
He's introducing heat, therefore convection.
Gets complicated with candles, doesn't it? Maybe streamers would be better.
The more objects that were in that room, the more pockets of air you would have as well.
If it didn't move, you would be assuming that friction didn't exist at all. Right? Yeah. If nothing, if it didn't move and it stayed stationary and the room moved around it, then there would be clearly no friction, and we know friction is a force, and we know it exists. So I'm struggling with why this is so difficult. I don't quite understand why.
I don't think that it would be perfect secondary to the friction and air resistance and things like that. It may not be exactly perfect, but it'd be damn close.
Yeah, I don't think it'd be perfect, Bob. Of course not. There'd be all sorts of sort of currents that would, depending on the shape and how it moved, but it would be pretty good.
Which also goes to say that yes, there's maybe some slight differences in the movement, but actual wind currents in the room, because somebody farted on one end of the room and blew it over towards the other, are much greater than any of these little effects that you're dealing with. Much like an airplane, the winds, turbulence. These are things that are much greater than any potential change due to Coriolis.
In that scenario, would we have to compensate for the change in atmosphere? Sorry.
Have you ever made a hard left turn after farting to get the co-pilot?
I think one of the problems that we've had in this whole sort of series of debates around Coriolis, from my point of view, and it is a complicated thing, and I'm certainly no expert, and I absolutely share that fact, is that a lot of people have explained it in sort of a number of different ways and said, oh, you're a little bit wrong, you're a little bit right, you're a little bit different here. And then, of course, yesterday, Ranty is now sharing widely this guy who isn't even a PhD yet, who's come up with some calculator that appears to be, at best, a little bit misleading. Yep, certainly the quote that he's used about planes suddenly heading, what was it, to the southwest, I think I saw yesterday. Great circle routes don't seem to exist for this PhD guy. Yep, sorry.
No, that is his problem. There are no great circle routes, and
which is a nonsense, because the great circle routes are one of the best proofs. Bob did a great video. He did a great demo. I don't know if he ever recorded it. A great demo one day for me and some others, where he actually drew this route, and I've wanted to capture that ever since, because you could
Oh, you can
actually
do it
fly
yourself
that
right
route.
now.
Oh,
Yeah, you can do it yourself
How can I
right
do it,
now.
Bob? Because I was trying to explain it to flat earthers the other day, and I was trying to say you've actually got 3 great circle routes in a triangle. You could actually fly it.
Yep.
You could actually
Yep.
see the towns you're going over, and that
Yep.
absolutely proves that the Earth is curved,
Not
right?
flat.
Yeah.
Yeah. All you do is you go to a program or a website called skyvector.com.
Hang on. Let me get the notes, Bob. Hang on.
Skyvector,
Vector,
one
yeah.
word, .com.
Uh-huh.
And then in the upper left corner, it'll have a little thing there that says flight plan.
Mm-hmm.
And put the following airports in.
Mm-hmm.
You ready?
Mm-hmm.
JFK,
Mm-hmm.
LAX,
Been there.
Mm-hmm.
Been there.
ANC,
Mm-hmm.
back to JFK.
Brilliant. Okay.
Where's ANC?
Anchorage.
I haven't been there, you bastard.
Okay, and so those 3, but what the flat earther said to me is, well, the maps might be wrong. So if you flattened it out, you could still be going in a straight line, but your ball Earth projection makes it look like a curve.
Well, what'll happen is as you take the sphere and you rotate it up so that one particular course is directly going right over the crown of the sphere, it'll be a straight line between the 2 cities. And then you rotate it over to the next one, it'll be a straight line between those cities. And then you rotate it over to the third one, straight line between those cities. But if you look at it from the center of the triangle, or if you measure the angles of the course that you would have to fly, it comes up to 205 degrees. It's an absolute proof the surface of the Earth is not flat.
It's a perfect proof, yeah.
Bob, will it take those identifiers that way, or does he need to put a K in front of them?
Well, you may have to put a K in front of LAX and JFK, and you may have to put a P in front of ANC.
NCP, okay, right.
That candle demonstration is it needs 2 more candles.
Yeah.
That's pretty cool.
It's
I've
cool.
got a question for the flat earthers. If you put a battery-powered scale with a 500-gram weight on it, and it reads 500 grams on the open air, and then you put that in a vacuum chamber with air in it reading 500 grams, when you pump all the air out, how much will that weigh?
We're back to the Spurs one. We went through a load of these, didn't we? Let me think about it.
I don't know.
Well, you don't?
It would weigh the same thing.
It will weigh exactly the same thing. No, it'll weigh exactly the same thing.
It will weigh more because you will remove the buoyancy of the air displaced.
That's right. Yeah, there'll be a slight difference when we did this before, because Spurs did a gotcha with us on this. We had a long debate on it. Do you remember with the open syringe? We weighed the syringe and then we closed the syringe. Do you remember? And there was less surface area. We changed the volume, I think, of the object being weighed.
So this is a different example, right? If you measure the weight in air, you will be measuring the weight of the object minus the buoyancy of the object. And if you measure it in vacuum, you will just be measuring the weight.
Yep. I think you're right. You would replace the volume of the mass of the volume of air.
So
you would
therefore,
change the weight by the mass of the volume of air for the reference weight.
Exactly. So therefore,
it'll weigh a
accurate
little
weights,
bit.
we should do them always in a vacuum chamber then.
It'll be a little bit more in a vacuum. Yes, it'll weigh slightly more.
It'll weigh the
Whatever
mass
the weight
of
of the
that
air.
volume of air.
Yeah, whatever that volume of air, the differential.
That's a good point. I hadn't thought of that. Nicely done.
Yeah,
Really,
yeah,
the differential of the weight of the object and the weight of that volume of air.
We need a pretty sensitive. What volume of air? The volume of air that we're then removing from the container.
The volume of air that would equal the volume of the mass.
Of the mass.
Of the reference weight.
Right. So if you've got your 500 big kilogram weight, it's that volume of air, which probably isn't a lot,
so
is it?
it'd be 20
Right.
cc's, the mass of 20 cc's of air or whatever the volume of the weight is.
Perfect. Got it. Agreed.
That's a great point. I like that.
Somebody did that. What's that guy's name?
The guy was called Applied Science. Yeah, he showed that. Do you remember? Because we did this with Spurs, and Spurs was trying to get me on trying to say whether it would be heavier or lighter, if you recall. I think it was Applied Science did this. Yeah.
Somebody brought up a dive tank the other day, how the dive tank sinks when it's full, but when it's empty, it floats.
Yeah, that was John Watson. And there is a significant difference in the mass stroke weight of a dive tank when it is full and when it is empty.
Yes, it is.
I always.
Yeah, of course. You've got compressed air inside the tank, have you, or oxygen, or what have you got in the dive tank?
Well, in mine, I've got 9 litre. I've got 9 times 206. 9 times 206 bar of 9 litres times 206, because that's how many bar I've got of air in there.
Okay, but that air has got a weight then, hasn't it? I mean, I presume you've got a liquid in there under that pressure.
No.
You? I don't know.
No,
It's not liquefied.
I'm only talking 207 bar, so 3,000 psi.
That's what my air bottles run at for paintballing. We run at 3,000 psi.
So it's just very compressed air. It's not actually liquefied at all.
Oh yes, it's not liquid in there.
Right.
It's amazing how heavy air actually is when you think about it as being really nothing, but it really does have a.
But it's still got a weight then. Yeah, it's still got a weight.
Try filling it.
I got another flat Earth question if you guys have time.
Yeah,
sure. Go ahead.
Go on.
All right. Standard atmospheric pressure is 29.92 inches of mercury at 59 degrees at mean sea level. Let's just make that a given, okay?
Yeah.
So at the surface of the ocean, that's the pressure. 10 meters down, the pressure's twice that. Now, what I want to know is, where's the container that keeps that higher pressure down 10 meters down from bursting through the 1 meter into the pressure of the air?
I have asked that same question without result.
And where's the container? Are there walls to that container?
Well, of course it's different because it's a liquid. Liquids are going to have an upside down effect.
There is a container, and it starts with the letter G.
I was doing a really crappy Spurs impression. My apologies there, Bob.
Oh, that was awful.
But I'd like to know where the container is. I want to know where the container is that keeps that parcel of water 10 meters down from bursting through the surface. Why isn't the ocean covered with fountains?
It starts with the letter G.
Yeah,
and it's not Greta.
Well, why is it not heading towards the air? It should be fountains, you're right, because under Anthony Riley's idea, it always heads towards the lower density, doesn't it? Remember? He said to me when I did my ball of water with
the lower pressure.
Yeah?
Yeah.
Right.
That's right.
And
so it should be fountains. Should be fountains everywhere.
All over the ocean. Why doesn't that happen? And where's the container? Show me the barrier. If you say that there must be a barrier, show me where the barrier is. We all see the ocean. Where's the barrier on top? Is it covered in fucking saran wrap?
It's in La La Land.
I know. It's the surface tension, Bob. It's the surface tension.
Could you imagine how much energy would be able to produce if that was true?
Okay, so basically,
sorry, that was supposed to be facetious. Remember?
Okay, so if it's surface tension, then we couldn't blow air at the same pressure and dig a hole in the surface of the ocean, then, right?
So that's
sorry, I'm not a good enough fluffer to be able to answer that one.
My biggest issue with a lot of the things they come up with is exactly what Druss just said, which is a very good point. You would have a lot of perpetual energy machines. Yeah. If you took on board a number of things that they say, it would be quite easy, I think, to come up with something that would run forever. Yeah.
Well, they believe in perpetual energy.
Yeah, a lot of them do.
Yeah, well, come on, they believe in the flat Earth, so they believe in anything, don't they?
But you sort of mean the
Yeah,
point that we've just made, right? If there's no barrier, and it always goes upwards.
Ah, shoot. Montreal is not there. I really wanted to ask him about that. I thought maybe he might like to debate me.
He's here.
Yeah, he's here. He hasn't left.
He's just
there you are, Montreal. Why don't you answer that question, Montreal?
He's in La La Land.
The question that I asked is, since atmospheric pressure is 29.92 inches of mercury at the surface.
Right. You're breaking up.
Bob, you roboted.
Yeah, Bob, I think you lost your
meters
signal.
down in the ocean, the pressure
I want to know why that higher pressure doesn't burst through the surface of the water and the ocean is covered with fountains.
Bob, you're gonna have to start again. We lost the first 15 seconds.
You broke up with re-entry.
All right. Am I still
You're good.
am I still
you're
doing
good.
okay?
Yeah,
I must be in that blackout.
You're good.
I think
All
Meeks
right.
is
Now,
having
on the
some
surface,
problems.
at sea level, pressure is 29.92 inches of mercury. 10 meters down in the ocean, the pressure is twice that. I want you to explain to me exactly why that double pressure, only 33 feet away, doesn't burst through the lower pressure of the surface of the ocean without a container or a barrier. And if there is a barrier or container, I want you to tell me what it is.
I haven't thought of this question. I don't know, but I want you to explain me.
Wait.
Okay. Answer.
I want you to
Now
show
you have
me
something to try and figure
pressure.
out.
I want you to show me pressure without a container first, and then I'll answer your question.
He just did.
Bonus probando.
That's the example of pressure without a container.
No. What you showed me was water in a bowl.
No.
The earth. Call it water in a bowl.
No, water
contained
in
in
an
the
ocean.
earth. That's all you showed.
Where's the container?
The container is the earth, the side. You know the beach? You know when you walk, and when you walk until you hit water, like Bob says.
No, the container
that would be the container.
Okay, so
It
Montreal,
took me
Montreal,
longer to explain the question than it did to win.
Montreal, completely agreed.
You're 0 for 2.
The banks and the shores of the seas are the sideways container, sides of the container. The bottom is the bottom container. What's preventing it from bursting out at the top where the pressure is lower?
Nothing is preventing it. It's the water itself. It's self-contained. What don't you understand about that? I pour water in a glass and it stays there. Period.
So you mean like the
That's
atmosphere or this?
So
Oh, look at
water
this.
is a container?
Look at the
No,
mid-
I said I put
water
water
is
in a
soup and
glass.
water
Listen carefully,
when I go
Schrodinger.
to work?
I put water in a glass and the water stays there. No explanation
What
needed.
keeps it in from the top
Yes,
where the pressure is lower?
Is
No
water
explanation.
container?
No further explanation
The
needed. You guys are going to come up with
pressure-
explanations.
Does
I
water
see
go
me
from high
pouring
pressure
water
to
in
low
a glass,
pressure?
and the
One at a
water
time.
stays in the glass.
The pressure at the bottom of the glass is higher than the pressure at the top. Why doesn't the pressure at the bottom burst out the top? There is no container at
What
the
are you
top. The
talking
container is
about?
open.
What kind of nonsense are you guys coming up with? I take water from one place, I put it in a glass, and the water stays there. I
Higher
need
pressure
nothing more
moves
to
to lower
explain than
pressure,
that.
correct?
That's
Why
all
doesn't
I
it
need.
explode out of the glass?
Why should it explode out of the glass? It's just there.
Because the bottom is.
Because the high pressure should rush out of the low pressure, right?
Right. Higher pressure moves to lower pressure.
Yep.
Correct?
10 meters below the surface of the ocean, the pressure is twice what it is at the surface. Why isn't that higher pressure bursting up
Because
through
very
the
simple.
surface?
Because the water is heavier than the air it's in. Hello.
What makes it heavy?
Nothing itself. You don't need gravity. You don't need anything itself. The
Okay,
weight of the water itself makes it heavy.
Well, why is the
Montreal,
pressure lower?
Montreal, wait. Montreal, in
He
respect to the
literally just said
atmosphere,
because reasons.
in respect to the atmosphere, which is heavier, air or vacuum?
In respect to the atmosphere,
Yeah. Which is heavier, air or vacuum?
well, obviously.
Air,
air.
obviously, right?
The air, obviously, yes.
Well, therefore, we don't need the top container for the atmosphere. It is just being...
In your la-la land, we don't need the top container. In your la-la
In
land,
your
but
La
in
La
everything
Land,
else
you
in
just gave us
science,
the perfect
You can't
La La
even
Land
be
mentioned
consistent, can you, Montreal?
Montreal.
It is heavier than the vacuum, so it goes down and it stays there, right?
What are you talking about?
You can't even be consistent, can you, Mr. Ninth Grade? You don't even understand the question, do you?
What are you talking about, Professor? Be more specific.
Exactly.
Maybe you could tell me why this butane's just sitting in this pipe under pressure with no cap on the top of it. It's
No,
an
let's
open
let's just go through this analogy again. So you say the pressure of the water stays in the sea because it's heavier and therefore it sinks down, and that's why we don't need a top covering the sea. So great. Okay, fine. We're down with that. The next point was, well, you just agreed that the atmosphere is heavier than the vacuum. You've already said that, a higher pressure doesn't need to go to a lower pressure if it's heavier. That's the point you've just established. You've agreed that the air is heavier than the vacuum, so therefore that's why it goes down towards the Earth. Done. We don't need a container.
I'm so relieved.
No, hold on. Let me speak. If what you say is true, and above us is a vacuum, the atmosphere would dissipate immediately into this vacuum. How could you not see that?
Why doesn't water do the same?
Why isn't this butane doing that?
What?
Why doesn't water burst into the air?
All right, let's stop and let Blue go for a second with this butane description to.
Go ahead.
No, I'm just curious. It's the same problem.
I think you'll confuse him. So very simply, Montreal, the water that's under pressure, that's 10 meters under the surface of the sea, why doesn't that go and fill the whole space? Why does it stay there under pressure? Why? Just like Nathan's saying, oh, it will absolutely, due to entropy, fill the container. Why doesn't that pressurized water do the same? Why does it stay there 10 meters under the sea consistently at pressure? Why does it not just spread out?
Because the water on top of it is pressing on it. But what's pressing on the... If what you're saying is true, then let me reverse that to you. What is the atmosphere pressing up on the way on the top where the vacuum is? What's that part pressing on?
It doesn't need to press on anything in your model.
Yeah, it does, because the definition of pressure is something pressing.
You've already agreed that the water stays where it is because it's heavier. You've already agreed that the atmosphere, and the atmosphere is a lower pressure gradient than the water is. Fine. So it stays there because it's heavier. So you agree that a higher pressure won't rush to a lower pressure if it's heavier. You also agree that the atmosphere is heavier than the vacuum outside it. Ergo, under your model, using your logic, you have just agreed that the atmosphere sticks to the Earth because it's heavier.
Or can, at least.
I agree to nothing of the sort.
That's what we call a boom, gentlemen.
No, that's not what you call a boom. What you call a boom is show me pressure without a container. Go. One example.
We just have.
He just
we
did.
have water pressure. We've just
no, you haven't.
It's on the screen right now.
No, you haven't. You explain how the Earth works. You haven't explained. You haven't shown anything.
We have just shown you pressure that's contained
in your mind how the Earth works. By the way, in your mind, in your la la land.
See, this is really unfair. They just don't get it.
He's really trying to make tea come up my nose again, isn't he?
Let Big Blue go, because he's actually got it on screen showing air pressure without a top to the container, with nothing above it, nothing.
I think it just models Montreal's mindset, though. I mean, I love Blue's illustration, but
Yeah, I probably will. But the thing is, he's just said that the reason that it doesn't,
because we keep moving on to things, we should labour the one point, because he's absolutely inconsistent and he cannot explain it, and it is a boom moment. Sorry, it is. I feel
no, you're trying to trick me. You're trying to trick me with water, with this.
There's no trick. What's the difference between water and air, then?
Enough to realize it's a boom moment, though. That's the problem.
No, it's a kaboom moment, but on my side, not on your side.
Montreal, look at the screen.
There's the third one right there.
Look at your screen.
Wow.
I'm looking at it.
That's gas pressure in an open system. That pipe is open at the top. It's maintaining gas pressure. According to you, an open system with pressure would immediately disperse into the atmosphere. Immediately. Why does it not do that?
Because it's pressing on the sides. And what kind of gas do you have in there?
You
have it too. Why don't you show me that without your contraption?
What is wrong? What is stopping it from going out the top of the pipe?
Okay, Bob, here. You want to convince me? Here's what you got to do.
There's the pipe.
I'm trying to barbecue right now, and I ran out of gas. I want you to go to the place where I can get gas, but I don't have my container with me. Bring me some gas, fill it up without a container, and you got me, buddy.
Montreal, I don't think you realize that you're...
Why does it have to be propane?
You realize what you're asking for.
Montreal, you're being an ass.
I'm not being an ass. I'm trying to show you how silly you guys are.
This is gas. No, this is gas pressure in an open system.
I said it would confuse
I'm talking
them.
about
He can't
containers.
understand it.
That is, containers are not.
Okay.
That's not a term
17
that's
is
even used
live.
in
I'll
science.
see you guys there.
Talk about open systems.
Can,
Closed systems or isolated systems.
Bye, bye.
This is an open.
Can,
It allows
Guys, I gotta
free
get going, too.
exchange of both energy and matter. It's open. The top of the pipe is open. It allows a free exchange of both energy and matter. That's the definition of an open system. And according to you, because there's pressure here, that gas should disperse into the atmosphere immediately, but it doesn't. And
What
it doesn't
gas is in that
because of
pipe?
gravity.
What gas is in that pipe?
Butane.
Is butane heavy in the air?
Yes.
Yeah, it is. And you know why?
There's your answer. There's your
Because of
answer.
gravity,
It'll
buddy.
take
you know
time,
what's
but
heavy?
eventually
Gravity.
it'll leave that pipe.
No.
Given long enough
why?
time, entropy
No, it
will
won't.
take effect and game over.
No, not game over. Why does it not leave that pipe immediately? It's under pressure. It should go out of that pipe immediately, according to you.
Because it's heavier
Why
than
didn't
the
that happen?
surrounding air.
Hey,
It's
you know
heavier
what?
than the surrounding air.
good,
And
then
it's
the air is
confined
heavier
by the
than the
side.
surrounding vacuum.
Whoa, hold on. And it's
Thank
confined
you.
by the side by that pipe. Take that same gas
It's not
and
confined
disperse
by
it
that
into
pipe.
an open thing. You're going to see it's going to disperse
That is
equally
open.
in all
That
directions.
pipe is
Can,
open. By definition, that is in physics, that is an open system. The top of the pipe is open. It allows for the free exchange of both
So-
matter and energy. How many times do I need to tell you this?
Montreal, it's not just like a liquid of gas just sitting in a slopping thing, right? Just staying there. It's under pressure. You do understand it is in that pipe, but it's also under pressure. It's not
Yeah.
just like it's just been poured in there. Yeah, and it's just sitting there because it's heavier than air, right? Which would be reasonable if it was, I don't know, like a liquid or something, right? It's under pressure still. It is pressurized still. So it should expand to fill the space of the container, right?
It does. It's just going to take more time. That's all.
No, you're
Can,
talking about both sides of your mouth now, Montreal.
Yeah.
can I take a stab at this?
It either expands immediately or you're wrong.
I want to hear
recommend
how
using a
long he
spoon.
thinks it'll take for it to expand.
I left it there for 2 fucking days.
You just took my thunder, Blue.
I'm sorry.
I want to know from Montreal, what is your calculation to show how long that gas will stay in there before it disperses due to entropy? Because it's heavier.
I don't need calculations. It will disperse eventually. Yes or no?
And how quickly?
2 days. He just told
He
us.
left it sitting there for 2 days. It still didn't
It doesn't
disperse.
matter. It doesn't matter. If you take the same gas, don't restrict it in a
never?
tube. Let me
How about
finish.
never?
Let me
How
finish.
about never?
It won't go anywhere until it physically dissociates.
Yeah, but it's not. It's in a barrier. You still
Not
have
in
the
a barrier.
walls of the
It's
tube
open.
there.
It is.
Can I take a stab at this?
Go ahead.
Okay, let me tell you something. How many walls does the Earth have around it?
It doesn't matter. If
See,
you were to pour this on
you're not equivocating.
Montreal, listen for a goddamn
You're
second.
giving silly examples here.
Montreal.
Well, the ocean has 3, just like that pipe. How about that one, Sonny?
I told you it's heavier. Water is heavier than the air, so it stays
Can I?
lower.
Why is it heavier?
Montreal.
Unpaid
Montreal. Let me try to possibly clarify some things you might not be understanding, as they're putting it. We experience air pressure, correct?
Yes. Before you continue, I don't
Okay.
want to think that I'm running away. I have to leave in 5 minutes because I have
Okay.
something to do. But I will come back after. Don't
okay.
anybody think that I'm running away from this.
Okay, I get it. I've
All right.
had appointments too, and I've had to step out of here about 4 times. So I totally get it. I understand. So we have air pressure, and you acknowledge this, correct?
Correct.
At sea level, it's approximately 14.7 psi, right?
Correct. 760, whatever you call it.
760 torr,
Torr,
or
that's right.
6,400 mil, if I remember right. Anyway.
Correct. Indisputable.
Yeah. So let's say we go up to the top of a mountain. Does the air pressure get lower when we get up to the top of a mountain?
Yes, also indisputable.
Okay. There's no barrier between sea level and the top of that mountain. Therefore, you've got gas contained at a high pressure, and there's no container. What's going to prevent that gas from rushing up to the top of the mountain?
Reasons.
Yeah, I think he just said indisputable, actually.
Twice, yeah.
It wouldn't matter if I poured that butane on the floor. It would always stay at the level. It always stay at the level that it's going to be at until it dissociates.
And by the way, thank you, panel, for giving me my moment. I appreciate it.
And by the way, the pressure in that pipe does exactly what the atmosphere does. There is a gradient in the pipe. At the very top of it, it's 0. Down here, 24 feet down, it's 0.35 inches of water.
In order to have pressure gradient, you first must have pressure, gentlemen.
And there's the pressure right there, sir. 0.35 inches water.
So what's it pressing on top at the high up where the part that you call space? What's it pressing on up there?
Let's continue this. Hang on. Let me Montreal, can I go ahead and continue then if I can provide some further clarification for you?
Yes, but literally I have 5 minutes and I have to go.
That's fine. That's fine. I can make this quick as long as you work with me. Okay, so undisputably there's about 14.7 sea level less at the top of a mountain. Would you say there's less air pressure up above that?
It would logically appear so, yes.
Right, and it will continue getting less the higher you go, correct?
Correct.
And eventually, according to my calculations, somewhere around 44,300 meters, it gets down to a pressure of functionally 0.
See,
so the atmosphere. Hang on, please allow me a moment to summarize. Sure. So essentially, what's happening is the atmosphere isn't just atmosphere, then all of a sudden a cutoff to a vacuum. It's a smear of gray. It goes from thick towards the ocean surface, and then as we rise up, it gets thinner and thinner and thinner. There is no atmosphere next to a vacuum. There's simply a smear of atmosphere. And I'm done. Thank you.
Very well said. Very well put. I realize this is the explanation. I get it. Trust me, I understand it fully. But it cannot be so. If you think about it logically, it cannot be so. It has to be pressing on something in order to have pressure.
You
can't press on a vacuum. It cannot. It's against the laws of physics, guys.
It's
It
actually
cannot happen.
It is actually in a container. You basically, your atmosphere is pushing on itself as you go around a sphere, and there's all this force pulling down. It eventually reaches itself and pushes on itself, just like a really big container.
And furthermore, thank you, Montreal, for being respectful to me. I appreciate that as well.
I'm always respectful to people that are respectful to me. Always. Guys, really, I have to go. We can pick this up later on or another day, but I really have to go.
Understood. I understand completely.
Montreal's
It's been a pleasure talking to you
otherwise
guys.
he's going to be in extreme trouble, would be my guess.
Exactly. I might have to let some guys out.
Later, Karen. Have a good one.
See you, Montreal.
Later.
Catch you later.
Later.
Okay.
I'll take it back. I liked Montreal until today.
And then there were none.
I certainly hope that I had a boom moment there.
Yeah,
I think that was a very
I
true
think the
moment.
indisputable probably was when he admitted and then didn't realize it, obviously, that up the mountain there was a lower pressure and there was no container between that and sea level. I think that
Laws
was,
of physics given to us by a 9th grade dropout.
I think the trouble is, right, we do really move on very, very quickly. Maybe our minds can keep up with the pace of the different examples. But I think, we really did have it with Bob's example of obviously the sea and the containment there. I think because we're so keen to show them so much, I think we almost sometimes do ourselves a disservice, because I don't think they can follow the train maybe quite so quickly. I'm not being, conceited there. I just genuinely think that might well be the case. Yeah, and we're so keen to show them lots of different examples that then it's very easy to, obfuscate between those different examples. Yeah.
Are you guys ready for tomorrow or later on tonight when he goes under Sean G's and pairs the same points over?
I might jump on for a laugh and listen. What I did do is I did send Travis the correct definition for begging the question fallacy, and I also pointed out, yes, it's also a circular argument which means it's also a fallacy from that point as well, which is why I made both points. So hopefully he'll know now.
Is begging the question, is that the one that's like if P therefore Q, Q therefore P?
Basically, what you're doing is you're affirming the conclusion in your in one of your premises.
Okay,
I think Nathan misuses that, by the way. Yep, he says everything is either the reification fallacy or if P then Q, then P then Q. Yep, and it's that and reifying. He says it's either reifying or it's affirming the consequent. And I think sometimes he misuses that because just because something is linked doesn't necessarily mean that if P then Q, then Q then P.
Yeah,
sorry.
So it literally would be.
And reification isn't what he says either if it's descriptive of reality.
Correct, yeah. And he assumes reification is just describing something and then affirming that that is the thing that you've just described, so therefore that's correct. If it's a correct description, it isn't reification. And the other thing is the fallacy, which just means that if there's a fallacy, it doesn't mean that everything is negated, yeah?
What you were talking about, Brian, is affirming the consequent.
Yeah.
By the way,
which is just another way of saying begging the question, which is again a form of circular argument.
In panel chat. Oh, go ahead, Blue. I'm sorry. Go ahead.
I was going to say, me bringing up the gas example was somehow interpreted as distracting. I've been through this before, and you're going to go nowhere with that water or argument. I promise you. At some point, they're going to say, "Well, that's just the ocean. That doesn't behave the same." You got to talk to them about gas. You can't just talk to them about.
I wasn't having a go, Blue. I just think that sometimes, there's a lot going on. Yeah, there's a lot going on.
In side chat, I posted a link to a little spreadsheet that I put together, and I intend to expand upon this spreadsheet that shows a few statistics about Earth, such as circumference at latitudes and speed at latitudes, things like that. And if anyone has any ideas of more things I can put on there, I'd love to expand it with more information. So just putting that out there, guys.
Do you want to
Blue,
keep that
have you...
to? Sorry, I'm pretty sure. Do you want to keep that just to the panel members, or do you want to put that in the outside chat as well?
For now, just for the panel members, because I want to make sure it's secure and nobody can mess with it, and
it's also fully editable as well. So make sure you've got a copy of it.
So
trust
Blue,
no one.
Blue, have you ever done a video on the thing that Bob was talking about where I took down the notes, the Sky Vector one? Because, again, for me, I think that's a very, very powerful one that people could validate, but I don't want to make a video and then find, obviously, it's already been done better, probably by somebody else.
I haven't done one of those as yet, but I'm seriously, after all of the nonsense that's gone on here lately, I'm seriously thinking about doing a video on how airplanes actually behave in terms of navigation to try to clear up some of this stuff and quantify how small that Coriolis force is compared to the wind we would typically deal with.
I think that would be pretty good, as well as covering what Ali was talking about with these altitude indicators. Yeah, I think it would be good too. Yeah.
Ali reads the stuff and can't comprehend what he reads.
Of course, the real problem with all of the Coriolis effect forces is that it is so tiny in comparison to many of the other forces that are acting on either a projectile or an aircraft that it's really hard to see it because, well,
it's about nearly impossible to see it.
Yeah.
All I've got to do is figure out what it takes to correct for a 30-mile-an-hour wind, crosswind. And that's probably hundreds of times it's more significant than Coriolis would be.
Which is why I think actually the Foucault's pendulum may be a better one to use as an example, because I think with Coriolis, it goes into this big, long, as we've seen, right, week-long debacle where one side says one thing, then another, and then another. I may start looking and filming some examples of Foucault's pendulum. I'm quite near the British Museum, so if they've got it working. I think it's a very good example, Foucault's, because it's pretty simple, right? With the sand. Yeah, go on.
It is totally. It is totally simple, and that is the problem when we're talking about projectiles being fired or airplanes or wind or cyclonic or anticyclonic flow around pressure systems in the atmosphere. Those things are very, very hard to say, oh yeah, we ruled out everything else. It could only be the Coriolis.
Yeah, the complicated systems, aren't they, with multiple factors that could all interfere with each other.
Absolutely, and no matter what you do, they're going to say, "Oh no, how do you guys know you know this and that?"
So
Foucault pendulum is straightforward. It cannot. There can be no other explanation for why it's doing what it's doing.
If I can make a point, the trouble with especially Travis obviously has a bit of a fundamentalist background. And there's certain methods of argumentation that they use from the point of justifying their perspective in apologetics. And he has learned some of this. He's had actual he's done a fair amount of biblical study. And this is all part of the methodology. So that's why they go down a reducto ad absurdum route, because they're just trying to really reduce the argument. So they'll always try and find a point of challenge at every level, and just trying to keep forcing you down to the point where you say, I don't know, and then claim victory. And that is the whole point of this method of argumentation.
Yeah, it's essentially flat earth pre-supping.
Yeah, which is why I don't fall for it, because the one thing I'm fucking good at is pre-suppers. Hi, Darth. So yeah. So just watch for that, because it's a really simplistic tactic, and in a way also Montreal kind of uses that method as well.
Yeah, but Travis is much better at it.
Oh, he is.
Yeah. Oh man. Apparently, Earth is seriously flat is presenting something on Sean's channel, attempting to prove a flat Earth using a light and a map that has actual geometry to it.
All right.
The only problem is that he just proved a globe.
All right. See you later.
Yeah, apparently he just proved a globe, and he has no idea.
He just did. It's amazing.
Excellent. I'm going to go and watch that. I will catch you guys later.
Bye for now.
Yep, same here.
See you, Dross.
Yeah,
See
I may
you.
have to join that pretty soon. He's got to be a Poe. He proves the damn globe every chance he gets, and then he says dumb things like directed energy weapon.
Yeah. Sometimes I wonder, sometimes they seem dumb enough, and then other times they are obviously not that dumb.
And then there's Montreal.
Yeah. The one that I'm really not sure about is Riley, because
he's got to be a pathological contrarian. He literally has every position possibly available that is against convention, even down to saying dumb things like the ancient Egyptians were an advanced technological society that had free energy, and you can tell because the pyramids have a granite piece that goes into the aquifer. So if you put whatever the headstone is back on the top of the pyramid, everything should just generate free energy.
Okay, whatever.
That was probably the dumbest debate I've ever listened to.
Yeah,
I watched GeoStreamer. Oh, sorry. Go ahead.
No, you finish. I was just agreeing with you.
Yeah, I watched GeoStreamer have that particular debate with him and explain to him the the conductive properties of granite and how very little energy that he could possibly generate through that. And Riley just seemed to think it didn't matter.
I was going to say, I would be quite happy using granite as a reasonable insulator. I mean, there are better, but you know, it's still. I'm not going to be. You're going to have a pretty damn big voltage before it's going to start conducting significantly.
And somehow he was going to get that off the friction of the passage of water against a static structure.
Yeah. But you can't really use static electricity for power generation because current.
And we agree. That's why it was probably the dumbest debate I've ever seen Riley in. I'm really surprised he didn't win Dumb Fuck of the Year for that one alone.
Yeah, I mean, sorry. Sorry, I'm sometimes not the quickest on the uptake of the stupidity, but yeah. So basically, they're trying to invoke static electricity to produce power. Nice one.
Yeah, Blue, you're more than welcome to chime in and explain why that's horseshit.
Well, current, really. You know, you've got to be able to actually do work, and static electricity doesn't exactly do any work, does it?
Not typically, no. Hey, I'm going to sign off, make some dinner, and maybe pop into Sean's later on.
Yeah, okay. I think we seem to be pretty much coming to the end of things. So if there's anybody who's muted who has anything they want to say, now would be a really good time. I guess in that case, I will say goodnight to those of you who are still watching out in YouTube land. It's been a nice evening, and I'm guessing I would suggest popping over and seeing what is going on in Sean G's. So, good night. Thank you very much for watching.